a strategic industry to Malaysia. It facilitates shipping, which carries an estimated 95% of the nation's trade, and the offshore oil and gas industry, which remains the backbone of Malaysia's economy. MITE, an agency under the Prime Minister's Department, intends to facilitate the SBSR industry to stay relevant in the event with the rise of the Fourth Industrial Revolution. Therefore, we are gathered here today to listen from various speakers who are experts in the related industries. Before we in a way, a blessing in disguise that we could not consummate that deal that we have already signed and paid the deposit. And then we are now in this building, which was designed for doing something else, not too different from us. But then that program fizzled out, and the building was left unattended, so much so that we have to spend quite a lot and, in order to bring it up to ground level, as it were, because all the wirings, all the transformers and switchgear are all been cutted away by God knows who. So we have to bring it back to ground level and then refurbish it to suit to our needs. And this is what we have. So welcome to MITE. Some of you may know us from the beginning, when we started off way back in the mid-90s under the Prime Minister's office. as the platform, government industry platform. We are celebrating our 25th year this year as MITE. And we have transformed a little, but basically we are still that platform for consultation between government and industry. We consist of members. Some of you are members of MITE. From government, they are non-paying members, as it were, ministries and so on. But from industry, we have paying members, some lead members who keep us alive, as it were. Then, because of the government industry, we have two joint chairmen. One is Professor Tan Sri Zakri, who is a science advisor to the Prime Minister, not here this morning. And the other one, myself, I was looking at my records. I think my current stint started coming up to 10 years ago now, because the first letter was in 2009 as joint chairman of MITE for industry. I'm not sure whether I'm government or industry. I'm confused also, but nonetheless, designation is co-chairman or joint chairman industry. We have divided our work between myself and Tan Sri Zakri. Those that's not involve golf, I take up, and those he take up. Those that involve golf, and then I will take up. That's the simple rule. Here, I would like just to say a few words with respect to maybe Industry 4.0 and a little bit about what I know of the shipbuilding and ship repair. I remember way back in, I don't know, Dr. Yusof, that particular Langkawi Lima, when the PM announced, I think 6 years ago maybe, about that. I remember that I was asked to come to Lima because the Prime Minister is going to launch our shipbuilding and ship repair blueprint, as it were, that we have developed. And that morning was very busy, of course. He was launching Lima, and then after that, he goes from booth to booth to booth to booth, and so on and so forth. And at the MITE sort of booth, we had two things that he needed to launch. One was this AMIC. I think that was the one. One was AMIC on one corner. So he went there to launch AMIC, which is our aerospace initiative with the university and so on. And then he walked across to this other place, the other end of our booth, and to launch the shipbuilding and ship repair blueprint. And I remember we have not briefed him anything about it. And I had maybe just 3 lines. Sir, thank you for coming. We would like you to launch our shipbuilding and ship repair this morning. This was prepared by consultation between the industry and government, and it was led by Tan Sri Ramli. I remember saying that. And then it is along the line of what we have done for the aerospace sector. Oh, good. So he just took the press or whatever, took the book, and then started flipping through and launched it. That's it. And then he went off. He went off. I went off also. Because I had to take a flight to Jakarta the next day. So I came back, and then the next day, I went up into the aircraft, took out NST, I remember. As the plane took off, and then read the headline, turned to page 2. There, right at the center of page 2, was the Prime Minister launched the shipbuilding and ship repair, and is almost half a page. He went on about shipbuilding and ship repair, how important it is. I know the briefing was that short briefing, that 3-4 line briefing, but the key word is, it is along the line as what we have done for the aerospace sector. And he elaborated. We saw so many things happening that morning at the opening of Lima. He highlighted this one. That I remember. And so that's how we started in this area. I remember since then. I know that Tan Sri Ramli has been more involved, has been part of the industry, as it were. I remember going to Cebu, I think, where we had one seminar consultation or something. And that's my little bit of knowing a little bit about ship repair, that it is quite a big business. There are so many 100 over shipyards around the country and so on and so forth. We are in, but not really in, and that's among the reasons why we are here. Let me put into the context of Industry 4.0. MITE, together with the Academy of Sciences Malaysia, have been tasked by MITI to do a write-up of Industry 4.0. MITI has done the consultation, established 5 task forces, involving infrastructure, which is headed by, for I 4.0, which is headed by multimedia ministry, multimedia communication, on standards and science by MOSTI, on HR by Ministry of Human Resource, MITI itself took one, and so on. So 5 ministries were involved, but they developed sectoral reports, as it were. And MITI does not, maybe, is at a loss of what to do with it, decided to call on MITE and the Academy, and being the past president of the Academy and co-chairman of MITE, the 2 organizations say, Tan Sri, please chair, supaya dia orang tak berkelahi. Yeah. So we've done the report. It was put for public comment about 3 weeks ago now, that the thing that was to be made public on the Industry 4.0, the implications and so on. But the full report, I think, will be tabled to Cabinet, maybe if there is a Cabinet meeting coming next week. Or is it this week, maybe? 11th. Then it will be tabled, and then after that it will be made public, the public part, after the solicitation for public comment that has been done by MITI. But the full thing will be made public after Cabinet has approved. So what is it, this I 4.0? Well, if everyone remember, Klaus Schwab, the CEO of World Economic Forum in Davos, about 3 years ago now, came up with this Industrial Revolution 4.0. Industrial Revolution 4.0, many people interpret it in many ways. Some people say there is no such thing. Some people say we don't realize it, but we are in it. It has been going on all this while. It is actually the digital revolution, not so much industrial revolution, so on. So there are many interpretations to it. There are people who just like to argue that there is no such thing and so on and so forth, but it doesn't matter. That will go on because there are people whose job is just to discuss things and keep on discussing and so on and so forth. So, but the fact of the matter is, what is real? Real is everything is going digital around us. We see the number of devices that are now interconnected, how dependent we are. Even as I'm talking, there are so many people, in front of their screen, either iPhones or smartphone or iPads or whatever, still working while listening, maybe. This is how things are happening today. While you are interacting with chatting with the family, chatting, there's so many things that we feel that we can do at the same time. So that is reality. But when it comes to industry, there are those that are directly impacted, and there are those that would say indirectly impacted, like it or not. There are those that know that they are going to be impacted, but do not know what to do about it, and there are those who do not know anything and couldn't care less. So depending who we are, we will fall into one of those categories. But the fact of the matter is, as a government, that's what we assist MITI. I myself am convinced that as a government, we have to prepare a platform, the ecosystem, the thinking that covers everything possible, as much as possible, because we are covering the whole nation, we are covering the whole industry. But that is the duty of the government to provide that total envelope, as it were, total picture. But looking from the other end, from the industry, from the user, from the rakyat, everybody will have to look at what's in it that is going to impact them, that they can do something about, or what is it, how they're going to be impacted, and how they can take leverage. Yeah? So that depends on who you are. If you're in the food business, the thinking should be, how is Industry 4.0 or this digital revolution is going to impact me in my business? It's got nothing to do with other things. I don't care. I'm not into entertainment, so it's not going to affect me. I want to be entertained, but it's somebody else who take business opportunity out of that. But when it comes to food industry, how can I use Industry 4.0 to help me to be ahead of the curve, to compete, to produce better products, to be more efficient in my production, or whatever the case may be. The use of that technology that is coming. Yeah? So the same thing with shipbuilding and ship repair. In my view, that's why we are here today, to look at this. How will this new development in technologies is going to impact on us, our competitive position, how others are using it that will impact our position, taking market from us maybe, or coming into our market and taking the business from us, or are we in a position to use the technology in order to offer a service that can be ahead of others and win business in the country and beyond? I remember, maybe 10 years more now, I visited at that time on the board of Sime Darby, I visited one of the outfits in Singapore. It's still there. I just checked with the CEO of Sime Darby Singapore. They're still in that business. There is this subsidiary of Sime Darby called Motion Smith. You might want to Google that. Motion, M-O-T-I-O-N, Motion Smith, who was at that time in the business of providing these naval or marine charts, the paper charts that the captain used at the board, in the old ways. I remember making a remark at that time. If you don't move, this will be outdated, because I know at that time already many ships are using radar, many ships are using digital maps, as it were, but they are still selling these paper maps. Yeah. So I remember telling the people there in Sime Darby Singapore, Motion Smith, to say that we have to move on, because I know at that time PSA, the Port of Singapore Authority, is already into this providing data to the ship before they come into the port, even for clearance and so on and so forth. But that's another part. But this is about the navigation side. So I just checked with the head of Sime Darby Singapore just now, who's still my golfing partner, friend, whenever I go down to Singapore. And he quickly replied to say, yes, we are still in that business, but we are in both now. Not just the physical paper chart, but also into the digital. Because if not, to me, they will be put out of business if they continue to be that. Now, we do not want our industry to be in that situation. So our effort is just a platform to bring together industry players, maybe with those relevant government agencies to discuss matters that hopefully can be value add to you as members of the industry. So with those words, thank you so much. Thank you for coming. And I hope you will find today's session useful. I'm sorry I cannot join you. I have another engagement in town, and then another engagement in the afternoon where the Minister of Science is going to launch I wear this, but I go there after, I don't know, I'll just put a coat on and hide that one, because it's under the Academy of Sciences. Minister is going to launch our 2017 Science Outlook, status of the science, as it were, in the country, done in 2017, launched in 2018, with this is the second one. We do once in 2 years, biennial report, as it were. Just like MIER does for the economic outlook, this is the science outlook. So thank you for coming. I hope you'll have a fruitful stay in mind. Sekian. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Your Bahagia Tan Sri. Distinguished guests, ladies and gentlemen, let us now welcome Yang Bahagia Tan Sri Ahmad Ramli Muhammad Noor, President of AMIM, to give his opening remarks. Ladies and gentlemen, please.
Thank you, Tan Sri Tajuddin. I think your opening remarks certainly enlighten us quite extensively from what Industrial Revolution 4.0 is all about. I think Tan Sri Tajuddin and I have known each other quite a long time. When we were still budding, what do you call this, government officers, more than 30 years ago, we attended a course where a clinical psychologist analyzes very accurately. And surprisingly, not only our characters were analyzed, but also our career was also charted at that point in time. And I think it was not very far off. So probably I think Tan Sri has known that this subject needs a bit of reinforcement. Probably I will not cover it as well as he has done. So thank you very much. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Yang berbahagia Tan Sri Dr. Ahmad Tajuddin Ali, Joint Chairman of MIC. Yang berbahagia Datuk Dr. Sulaiman, Dr. Yusuf Sulaiman, President of MIC. Yang berbahagia Datuk Engineer Ahmad Murad, Vice President Marine Industries or AMIM. Esteemed participants, ladies and gentlemen, a very good morning to you all. I'm pleased and honored to be invited in my capacity as President of Association of Marine Industries of Malaysia, or in short, AMIM, to this forum. My highest congratulations to Mike for putting this event together, which is very timely, given the sweeping changes brought about by the mega trend sweeping the world, affecting our industries, business and lives. dubbed, as Tan Sri mentioned, is Industry Revolution 4.0. It is changing the way we interact to one another, the way we buy goods and procure and obtain services, and the manner in which we carry out our daily activities, do business, trade, and many other facets of life. Ladies and gentlemen, to speed up Malaysia's move towards becoming a truly globally competitive economy and to transform its manufacturing sector into a smart and digitalized one, I think I repeat digitalized one as Tan Sri emphasized just now. I think Industrial Revolution is very much revolves around digitalization. The government has taken several initiatives at the national, state and regional levels. This entails working with industries, businesses and academia to develop a tailor-made solutions to meet specific needs of the respective industries to adjust to Industrial Revolution 4.0. These cover areas such as infrastructure development, financing, training and education, human capital development, regulatory framework, and many others. To this end, the government has introduced the National Framework for the Industry, which spells out a holistic and targeted agenda to transform Malaysia's manufacturing sector into a digitalized one. This underscores the acknowledgement by the government of the sector's importance as underlined by its 23% contribution to the national GDP. The shipbuilding and ship repair sector, or SBSR, is well positioned to catch the wave of this revolution. The industry has been accorded strategic status by the government, as outlined in the Industrial Master Plan. Given its importance to the nation's trade, economy, and defense, it creates a tremendous multiplier effect to the nation's economy and has linkages to many industries and sectors, including transportation, steel, plastics, engines and equipment, commodities, and a range of services such as financing, classification, naval design, legal, tax, research, and consultancy. Although most shipyards in Malaysia, most of whom are Army members, generally build middle-sized ships or vessels, not large ocean-going vessels, some are able to build fairly sophisticated ones and service large ones as well. Some build offshore support vessels to clients as far away as the United States, Europe, Australia, and New Zealand. The top shipyards feature cutting-edge equipment such as plasma cutters, which cut through electrically conductive materials by means of accelerated jet or hot plasma, and CNC or computer numerical control machines using computers executing pre-programmed sequences of machine control commands. Some also use huge cranes and employ processors that use sophisticated computers and even artificial intelligence. On this account, the SBSR industry is heavily influenced by the advent of technologies, although the industry in Malaysia lags behind in terms of sophistication and technological superiority compared to the world's major shipbuilding nations building large sophisticated vessels, and they are exposed to developments in shipping and SBR industries worldwide. With the momentum of Industrial Revolution 4.0 seemingly unstoppable now, sorry, I'm having actually a bad cough at the moment and a bit of cold. The SBSR industry, which uses various types of technologies and equipment and features many activities driven by ICT and data, of course, we cannot do anything, but we have to catch up and adopt to changes. Already, we are seeing IR 4.0 making a mark in leading shipyards in South Korea, Japan, Norway, and the Netherlands in areas such as big data analytics, cloud computing, artificial intelligence, robotics, additive manufacturing, or 3D printing and system integration. These developments are creating exciting new opportunities for shipyards and ship owners, along with the inevitable changes or challenges in areas such as changes to the SBSR workforce, processes and operations, and the end products and services. Ladies and gentlemen, with the new wave of development, they are bound to cause disruptions and bring forth issues to players in the industries affected. What more, the tsunami of changes brought about by the Industrial Revolutions 4.0. In this regard, forums like this provide a useful platform for stakeholders in the industry to share ideas, compare experiences, deliberate issues, and formulate solutions to adopt the new, exciting world of Industrial Revolutions 4.0 brings. I would like to congratulate Mike for leading the forum, and it is a pleasure and honor for Amin to be involved as co-organizer. I think the SBSR policy that was issued by the government, as mentioned by Tan Sri earlier, was the result of effort of not only AMIM, but all other industry players as well as the assistance of Mike. I'm confident that the forum will lead to valuable deliberations in preparation, in preparation by the government, especially Ministry of International Trade and Industries, in preparing for the blueprint for the National Industry 4.0. Thank you for giving me this opportunity to address this forum. I wish you a fruitful deliberation, and may you go away with key takeaways that can help you understand and prepare for Industrial Revolution 4.0 and unlock the values and reap the opportunities that this digital revolution has to offer, and face the issues and adopt to and overcome the changes that comes along with it. Sekian, wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Yang Bahagia Tan Sri. Distinguished guests, ladies and gentlemen, now let us begin with our first item on the agenda. Our presenter will set the scene by giving you an overview on Industry 4.0 in the SBSR industry. With that, please welcome Puan Sri Widyasuti to give a presentation.
Thank you, Mr. Megat, for the introduction. Welcome again to Mike. Alhamdulillah, lots of familiar faces here. Most of you are the expert in this industry, and I would like to say thank you to all my CFOs here. For Tuan Haji Salim, Encik Razak, Tuan Haji Osman, Encik Nazri, Encik Anwar, Mr. E, and Datuk Murad, and others. Thank you for all of your support. Okay, continue with the presentation. Lesson from Global Marine Trends 2030. It was produced by Kinetic, Lloyd Register, and University Strathclyde, Glasgow. Ocean is highway for international trade. Then Global Marine Trends demonstrate that the shape of the marine world in 2030 will depend on interaction between people, economies, and natural resources. From the report, mentioned that global population, global economy, commercial sector, naval sector, which is we have lots of procurement currently for RMN and MMEA, global resources, environment, offshore energy sector, which is very close with us, and disruptive forces. This driver is affecting global shipping sector, and Industry 4.0 will be falling into disruptive technologies. Technology trends in shipbuilding and ship repair towards Industry 4.0. From our finding, from our research, we find that nine technologies that into the trends towards Industry 4.0, which is data analytic, sensor, autonomous system, robotics technology, advanced material, advanced manufacturing, human automation, and clean energy, and also blockchain. In fact, Petronas already embarked to awareness program to promote our local vessel to use LNG energy. Okay. Adapting to the advancement and convergence of technology, here we can see this supply chain of the SBSR industry, which is from design into operation, then elements of Industry 4.0 along the value chain. We can see here 3D design, software integration, AR, VR, simulation, and others. This is important for digitalization of SBSR industry, and our Malaysian SBSR industry need to exploit manufacturing solution offered by the Industry 4.0 for production and operation technology, advancement for competitiveness. Okay, Industry 4.0 in SBSR leading countries. Our leading countries already embarked into these technologies. For example, robotic welding system for in Norway and South Korea, digitalization of shipyard in Australia, virtual reality in Japan, 3D printing in Ulsan, Korea, system integration in German, IoT sensor communication and big data analytics in German and also in Korea. Countries that have started in invest in technologies related to Industry 4.0. Looking to a patent registered perspective, this registration is from 2012 until 2017. The most invested countries is China and followed by Korea, US, UK and Japan. Both China and Korea, the registration is mainly for robotics technologies and followed by virtual reality. The investment of the technology varies in its application. For example, robotics in welding robots, virtual reality for training and simulation, for 3D printing, methods and material for 3D printers, and others. Okay. The technology is already there, but where are we in this playing field? Okay, later, other speaker will explain more on technology, government policy, and how we will survive in this era of fourth industrial revolution. Thank you.
Thank you, Puan. Distinguished guests, ladies and gentlemen, moving on to our next presenter, she'll be talking on Malaysia's National Industry 4.0 framework. Please bear in mind that this framework is crucial as it will give you some guidelines on how the industry could embark on Industry 4.0. Without further ado, please welcome Ms. Alia Muhammad Saleh, the Principal Assistant Director from the Sectoral Policy Division, MITI, to deliver her presentation.
Right. Thank you. Thank you to Mike for giving MITI the opportunity to present the draft National Industry 4.0 policy, which you have not launched yet, which you have also mentioned. We worked very closely with Mike and ASM as our partners in this because we wanted to make sense of what Industry 4.0 is all about and what we want to do in terms of policymakers. So what I'll be doing today in terms of for MITI would be to share the journey that we went to understand what is this fourth industrial revolution concept, how this applies to MITI, what are the current challenges that we're facing in Malaysia. I mean, everyone knows we are having issues in terms of moving to mechanization. What more Industry 4.0? So, and later on, I'll give you a sneak peek or overview of our National Industry 4.0 policy, which obviously would need to have been approved by Cabinet for us to share in totality. So firstly, when MITI wanted to understand this whole concept of fourth industrial revolution and what we wanted to do about it, rightly mentioned by Mike just now about how WEF was propagating this whole concept of it's the combination of internet with the new ability to directly control the physical world. So you could see where we are in terms of the cyber physical system. That's where WEF was propagating how fourth industrial revolution looks like. I'm not going to go into details on the first, second, and third because I pretty much think the industries will understand this on your own, and it could be to a certain extent academic as well. Right. So when we wanted to define what is Industry 4.0, we looked at how other people are defining it elsewhere. So we have people like the Germans who are talking about embedded systems to cyber physical systems. We have, the ISO RAMI 4.0 who talked about integrated processes and resources. McKinsey's, the Deloitte's, the PwC's, the consultants out there are also looking at providing specific solutions for Industry 4.0. So in terms of MITI, when we talk about working definition, we're talking about those that are adopted by the OECD definition. So we talked about the use of interconnected digital and associated technologies in industrial production and enables transformation in terms of the people, process, and technology. And this is to enhance efficiency as well as productivity and ultimately revenue. So we're quite clear here in MITI that we want to talk about Industry 4.0. We're talking about how it applies to manufacturing-related services, and ultimately, to a certain extent, the services sector. Because if everyone knows, Industry 4.0 is in itself coined by the Germans' initiatives. Because other names you see out there, the United States are using smart manufacturing, some other else are using industrial Internet of Things. What are the technologies driving Industry 4.0? So you've seen the first slide just now, some of the technologies, but these are the ones that we're looking as basis for Industry 4.0. We looked at the big data analytics, BDA, cybersecurity, augmented reality, additive manufacturing or 3D printing, systems integration, simulation, autonomous robots, cloud computing, as well as Internet of Things. Now, if you combine all this together, we talked about having the future of manufacturing. But these are just the 9 technology pillars that we have now, and some of these are actually not really mature yet in terms of the state-of-the-art technology. But there are other emerging technologies that are being covered by the policy framework as well. What are the prospective benefits of Industry 4.0? So we see when you adopt this new hand technology, it gives you a higher flexibility. So now we're talking about customization. A manufacturing line needs to be flexible enough that you can produce low volume but high mix. So in order to do that, you have to be flexible, and Industry 4.0 gives you that advantage. It also gives you the advantage of speed, higher speed from prototyping, mass production, and you use innovative technologies. You also optimize the current processes as well, and this includes productivity. You also talked about a higher increase in quality because now you can intervene the whole processes real time. And ultimately, it gives you a higher competitiveness. So when we wanted to find out what were the key challenges, why aren't industries in Malaysia moving to Industry 4.0, first and foremost, we found out that not many people actually realize that this affects them. So in terms of awareness, that's one of the key challenges for Industry 4.0. We also see that there is challenges in terms of best practices out there, and how do you share these best practices? And time and again, similar issues on skills and the technology know-how would also be there. Digital readiness as well, because some of these, especially the SMEs, don't think there is a need to move to higher end. There's a very high cost investment that is needed for you to go to Industry 4.0, and not to mention, of course, the data and cybersecurity concerns, and as well as collaboration and culture. So these are the government updates, meaning what we've done so far. It was a whole year, so we've done quite a lot actually. So stakeholder engagement, we've engaged our own stakeholders in various aspects of the government. So we have initiated a high-level task force in Industry 4.0 MET. We regularly update cabinets in terms of what are the progress of the National Industry 4.0 framework. We also stocktake the various initiatives on Industry 4.0 that is already done. So I'll give you an example, like Mosty already has the IoT roadmap. We have Education 4.0 under higher education talking about Industry 4.0 as well. We've also done an online public consultations. When we have the draft Industry 4.0 policy framework, we actually put it online, and we opened to public comments for about a month, and that was from February until March. We've also done benchmarking, not just looking at on paper, but also going to these countries and finding out where would the gaps be in our current National Industry 4.0. So you can see it over there in slides. We've also done various outreach engagement sessions. These are the major ones that we had in MET, which is last year in May, as well as in June. We also worked in collaboration with our other counterparts, such as the higher education, and this was a specific Dutch program who came just early this year. We also have related studies for Industry 4.0. So we have the MIDA Future of Manufacturing Studies, and this is one of them. In terms of what are the others doing out there in terms of our competitors, so you see USA being high up there, smart manufacturing, you see Industry 4.0, obviously China as well. So the main difference between the drivers of all these other countries would be a model of their being used. Either it's very much government-driven or public-driven, or a mix of both. And based on the benchmarking that we did, these are the takeaways that we could see feeding into what Malaysia is doing. So we looked at specifically SMEs, human capital and talent, technologies and standards, digital infrastructure ecosystem, as well as funding and incentives. Now, it's because when we established the high-level task force, these are the 5 working group areas that we're really seriously looking at what could we do in terms of Industry 4.0. So we have the digital infrastructure and ecosystem led by Ministry of Communications and multimedia. We have obviously the funding and incentives by Ministry of Finance, standards and technologies by our counterparts MOSTI. SMEs are specifically under us as well, so we're leading that one. And skills and talents by MO, co-chairing by Human Resources as well as Higher Education. Based on all these discussions, we pretty much find out that there is a need for government to work as an enabler for Industry 4.0. So what we need is first and foremost to develop a more comprehensive national level strategy, because it seems like everyone on their own realize the need to address fourth industrial revolution, but we're not talking to each other and leveraging on what each other's doing. So we felt that there is the need to have a comprehensive national level strategy in this part. Secondly, obviously improving the infrastructure as well as ecosystem relevant, because people were talking about if you don't have high speed, you cannot have Industry 4.0. We also talked about the necessity of government being providing targeted funding and incentives, particularly to the SMEs, because SMEs felt that they were pretty much left behind and we're not prioritizing them. And then if you prioritize SMEs, MNCs will come to us and say that, you guys are forgetting about us as well. So this is something that government needs to look into. And obviously, adequate supply of human capital and skills. This is obviously key. Facilitating development of standards and technology supply, and as well as increased overall awareness on Industry 4.0. So how does the framework look like? This is it. After a whole year of deliberating with a lot of stakeholders, industry, government, business associations, we've also talked to a number of NGOs, academicians, as well as our partners as well. We've pretty much decided that in 10 years' time, Malaysia should be the strategic partner for smart manufacturing and related services in Asia Pacific. Malaysia should also be the primary destination for high-tech industry, as well as a total solution provider for advanced technology. Now, these goals that we have identified, mainly 4 goals, are specifically to fulfill the visions. So we talk about labor productivity growth, manufacturing contribution to the economy, our innovation capacity, as well as the high-skilled jobs that we create with Industry 4.0. And we're looking at using the shift factors that we've identified, the people, process, and technology. So there are 5 specific, under the 5 specific enablers, we have 13 strategies in total, and you can see them on the slides. This is just a snapshot of the national goals and targets. So we have specific goals that we've identified in terms of productivity, that we're going to increase it by 30%. We're also looking at the contribution to move from 254 billion to 390 billion within the period of the policy. And we're looking at increasing our global innovation index ranking from 35 to 30 nations, and the number of skilled workers from 18% to 35%. Now, the shift factors that we're talking about here is essentially the people, process, technology, because without these 3 components, you wouldn't have the Industry 4.0 seamlessly at the end of the day. This is just a snapshot of the 13 strategies that is identified in the policy. I'm just going to read it out so that it's kind of small, I believe, but maybe some could see. So the strategy of F1. So we've coined using acronyms of FIRST, F-I-R-S-T, looking at where government could fit in as enablers. So we're looking at in terms of financing and outcome-based incentives. So the first strategy would be to provide outcome-based incentives, including tax incentives to encourage investments and adoption of Industry 4.0 technology adoptions. The strategy F2, to introduce dynamic and innovative financial products to encourage adoption of Industry 4.0 technologies and processes. In terms of enabling ecosystem and efficient digital infrastructure, we're looking at strategy I1, which is to strengthen the digital connectivity in and between industrial, education, and training hubs to remove connectivity bottlenecks, as well as for adoption of Industry 4.0 technologies. For strategy I2, which is to enhance digitalization and integration of government processes and infrastructure along supply and manufacturing value chains. And the I3 would be to involve service providers for Industry 4.0 and link them to manufacturing firms to help implement technologies, process, and skills developments. Now, based on our feedback that we got during consultation as well, regulatory framework, and industry adoption is also key. So we're addressing it in terms of awareness with R1 here, In terms of R2, we're talking about creating a platform and mechanism to help manufacturing firms, especially SMEs, assess and develop the Industry 4.0 capabilities. Now, this is actually an action plan that MITI has already undertaken as well. It's work in progress because we're looking at launching it on the same day as the policy itself. But we already have a standard guideline of how you assess where you are in terms of Industry 4.0. And we're looking at rolling out nationwide to perhaps provide a baseline in terms of this, as well as to assist in tying up to certain incentives. And in terms of strategy R3, we're looking at improving data integrity, standards sharing, and security to facilitate seamless integration of manufacturing value chains and to support inter-ministerial coordination for effective Industry 4.0 programs. So in terms of upskilling and producing future talents as well, strategy S1 talks about enhancing capabilities of existing workforce. So we're looking at upskilling as well as reskilling in this strategy. So for strategy S2, we're talking about ensuring availability of future talent. And then we talked about the smart technologies and standards that we need. Firstly, the T1 would be establish digital and technology labs and collaborative platforms. T2 would talk about establish and implementing standards for interoperability, quality, and safety for smart manufacturing. And last but not least, for T3 would be intensifying research, innovation, commercialization, and entrepreneurship. So out of these 13 strategies, there are actually 38 action plans outlined in the policy. It's not here, but it was in the uploaded document that we put for online consultation. It's still there on the website. You can't comment anymore because we've closed the period for comments, but we're still talking to specific companies or industries who are interested to come and see MITI and see how they could collaborate with us. So essentially, because this is not a launch policy yet, we are not revealing everything under the sun. So we are updating regularly on various platforms, including regional by state-wise. Our MITI offices in Sabah, Sarawak, Johor as well have talked about this with the state agencies as well as the industries. We're looking at more engagement and awareness programs as well. So one of them, we've worked collaboratively with Intel, who's going to come to MITI on the 12th of April, propagating the use of IoTs in manufacturing. So we're looking at more of those collaborative engagements in terms of this aspect. And we've also have a lot more inter-ministerial and private sector collaborations and seminars and workshops as well with other partners, and ultimately the launch of the National Industry 4.0 policy itself. So we're hoping that by 11th of April, it will be tabled to Cabinet and Cabinet will approve it and so on, launching it. So we, in MITI, we welcome more feedback from the industry and telling us what else could be done, because the strategies are there, action plans are there, it needs to be implemented. So in future, if you have any more concerns, our ministry is the one to go to. Thank you.
Thank you, Ms. Alia. Next, it gives me great pleasure to invite Mr. Nazri Khalid, the Honorary Secretary of Association of Marine Industries, AMIM, to deliver his presentation on preparing Malaysia's marine industry for IR 4.0, prospect, issues, and challenges.
Thank you very much, Yang Berusaha Cik Megat, pengacara majlis. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. Salam sejahtera, salam satu Malaysia, salam IR 4.0 to everyone. I think the stage has been set very nicely by the not only previous speakers but also our distinguished Tan Sri Tajuddin, Tan Sri Ramli, by setting the scene very nicely for us novices yang mungkin tak berapa arif tentang IR 4.0. I think it is something which is so profound that is changing our lives and our the way we trade, we do business, and the way we interact with one another to a point where we don't even realize it's coming. The fact that it is so prevalent these days menunjukkan yang benda ni dia tak ada macam mula dan akhir. As we could see from the slide that was shown by Puan Alia, was it Sri? You're the one that about the stages of the three previous revolution, from the advent of steam engine that first helped to mechanize the work of our previous ancestors, and then with the advent of industrialization of engines and so on, and eventually with computers, and now we are at the throes of computers, devices all talking to each other, and interacting with one another and bridging the gap between what is essentially the physical world and the digital world. So this is really something which is profoundly changing the shape of the world, almost irreversible. And this impact is being felt throughout industries. And I'm here to speak about the SBSR, rather the maritime industry, which has been subject to some of these changes, as rightly pointed out by Tan Sri Ramli during his opening remarks. We can already see a lot of examples of the impact of IR 4.0, all the components, all the enablers seeping through the activities within the supply chain of the maritime industry, which, as we know, consists of many activities. We, of course, AMIM represent the shipbuilding, ship repair sector, but also a lot of other activities that supports the activities of shipyards and also other activities such as shipping, port operations, offshore exploration, production, and many other types of services and so on. So hopefully by the end of this presentation, I will be able to enlighten you on how Industry 4.0 has impacted the marine industry and also bringing it close to home. Kita tengok some example of how it is affecting some of the activities over here. And also to highlight the importance of stakeholders in the industry to be aware of it, to prepare for the inevitability of the IR 4.0 impacting our business, and also to reap the opportunities which are inherent arising from IR 4.0. Jual lubat sikit about AMIM. AMIM is an industry association representing close to 130 companies. Mainly shipyards. Most of our members are shipyards, numbering close to 100 in the country, big and small, and also a range of other activities along the maritime supply chain that support mainly shipbuilding and ship repair industry, mainly like class societies, research, manufacturing, naval architect, provision of equipment, and also engineering services dan sebagainya. So those who have not become a member of AMIM, you can get the application form from me or from my executive Farah. Farah, where are you? Around here? Do visit our website at amim.org.my. The importance of the maritime industry to the country is, I think, cannot be overemphasized. It facilitates close to 95% of our trade by volume. So without shipping, without ports, our trade will come to a standstill. It will really choke the flow of movements of goods and also the provision of services in the country. And also, as we know, 20% of our GDP is contributed by the energy sector, of which the offshore energy sector is very important. And without, ships of all types, offshore support vessels supporting activities like exploration, production, we will not have the energy sector as we know it to be. So this is just to highlight the importance of the maritime sector to really put a strong emphasis on how IR 4.0 is affecting the marine industry and why it is important for us to discuss this topic. There are many subsectors, as I mentioned earlier, ranging from manufacturing part of it, which is relevant in the context of discussing IR 4.0, because one of the key activities within, one of the key enablers within IR 4.0 is additive manufacturing. Which is essentially sometimes known as 3D printing. And we can see that within the context of the national framework, which Puan Alia mentioned earlier, that we're trying to position Malaysia to become a center of manufacturing, which is moving up the value chain. We are no longer interested to become, a center which only produces assembly and sub-assembly of minor components. We want to move up to producing OEM, ODM, and so on. And really, the Malaysia's manufacturing sector is ripe to be a major beneficiary of additive manufacturing and also 3D printing, given that the technology is already available and there is a strong push by the government through the national policy framework to elevate Malaysia's manufacturing sector to move up the value chain. Let me allow me to cover, how much time do I have, Cik Megat? Yeah, okay, just throw the water bottle at me kalau I share my time. That's also part of IR 4.0, right? Because time is of the essence in IR 4.0. Again, it's been mentioned before how much this is impacting us. I mean, all the devices in our hand. Once upon a time, the kind of power that is packed into our smartphone, you needed a room full of servers the size of refrigerator, about a few dozens of them, just to have this kind of power, of computing power and the ability to, the interconnectivity with other devices and all the powers that can be packed into such a small device. And this is going to become even more impressive in the future. The smaller it is, and with the advent of semiconducting and also fiber optics technology, we have managed to really increase, the computing power, memory, and so on. So this is going to go on and on until probably, we can really pack a really powerful supercomputer into our finger, for example. And this is really becoming a game changer in the industry. A lot of shipping managers, a lot of people who work along the supply chain of the maritime industry. As we speak, even people who work in shipyards are still connected to the yards, to their team back in the shipyard, overseeing projects, giving instructions, looking at drawings, looking at photos of projects which are ongoing and so on. So this really shows the level of connectivity that we're having. And this has been made possible because of the fusion of separate technologies and devices talking to one another and being able to use a common platform in order to interact with one another. And this is really has transformed the way things are done, not only in the marine industry, but also in other facets of life. And so, of course, some of these are quite positive, and a lot of it have benefited us as persons, as business people, as industrial players, and so on, as decision makers, stakeholders. But it also caused what is now almost, overused word of being very disruptive. Disruption can also be creative disruption. It can also generate new things. It can also put us to a position where we need to be more creative and innovative to think of new ways of doing things and so on. So all the same changes and disruptions are a fact of life. But of course, with this, it brings opportunities, threats, and also plentiful of challenges. New jobs are being created, new opportunities, new ways of doing things, and those who are at the forefront of it and ready to grab the opportunities which are presented by RR 4.0 stand to benefit from it. Some of the changes, we can see that we can be quite pleased with the fact that at the national level, the government is doing something about it, coming up with this framework and also master plans. And this seems to complement other types of master plans, at least in the marine industry that we see, which is already in existence. For example, Tan Sri Ramli mentioned about our shipping industry master plan, SBSR 2020, which Tan Sri Tajuddin also covered a little bit in his speech, which was launched by Prime Minister during Lima, I think, 2007, yeah, okay, 2011. And also other master plans, such as the newly launched Malaysian Shipping Master Plan by the Minister of Transport last year. So dalam tu pun ada sebut about the importance to focus a little bit on preparing for the industry within the context of Industry Revolution 4.0. And then we can see that companies are now focusing on use IT, digital. It used to be just IT department that helps troubleshoot computer dengan orang punya device yang rosak, or you cannot connect the email. But now it seems that there's a range of new titles coming up from organizations. Now companies have, dulu kita quite familiar with Chief Information Officer. Now with the Chief Digital Officer, you have, now I've heard of a title called Data Scientist, which really, I believe, a combination of someone with an IT background dengan statistics. And then you have a Chief IR officer, and a lot of new terms which reflect the seniority of these people and reflect the importance of IR, which used to be on the periphery of management, but now it has been thrust into center stage. We can see that senior management now taking into account IT people, bringing them to senior management level meeting. They are part of the core management team and so on, which to me highlights the growing emphasis and acknowledgement of businesses on the importance of digitalization as a strategic agenda. And with that, of course, it demands a new group of people who are well-versed in IT and ICT and a lot of tech-related vocations. And therefore, the requirement for skilled human capital is also increasing. And then we can also see that there is a growing demand for awareness. There's real hunger out there. We can even feel it ourselves. Kita yang malas baca pasal IT pun tiba-tiba, somehow rather has to gravitate towards that, baca Quora lah, apalah, Quora. I talk about Quora like I know what Quora is. Well, I know it's one of the hot stuff dekat Silicon Valley. We tend to pick up, new things along the way and learn a little bit, because this is almost inevitable that we have to be at speed with this, or you will drown. Otherwise, I wouldn't be able to talk to my kids anymore, because you all talk in, in a different language which you don't even understand. And also, in order for you to reap the benefit and also the opportunities arising from IR 4.0, you need to be at speed with this. Although there could be some kind of a digital generation gap between pakcik-pakcik macam kita punya age ni, but the importance is there and it's undeniable. And then the millennials, Gen Y, Gen S, whatever it is, needs to be there within the context of a business and industries for them to help bridge the generation and digital gap between the generations. And of course, we can also see, I think Puan Alia also mentioned about collaboration being one of the enablers. I think this is very important because there's a lot of good research being done in the academia and also in research institutes. And some of them just remain as research findings. So what is important is to commercialize this research and also get them to come forth and see whether they can be commercialized and also be utilized by industries, businesses, and other facets of life. And then companies also, this is more pertinent, the last point, to SME, which I'm glad was being mentioned, because I think SME, bila ada disruption macam ni, they tend to be the first to be marginalized, or rather they feel marginalized, because of course like SME tak ada big budget macam GLCs kan, in terms of beefing up their IT department and so on. So they need a bit of hand-holding, and to this extent, I'm quite pleased to see that people like MDEC, Dato' Yusof, you mentioned that some of the major agencies are involved in the steering group of this formulation of the National 4.0 network, framework. Kan? So it's good to see that funding is made available, incentives, a bit of coaching, hand-holding to help them to step up the game in terms of immersion and also digitization, because when the wave starts to hit, the small players tend to be the first to feel the impact. Kan? And as what been mentioned, there are so many enabling technologies, and you can just look at all of this, and you can, although we may not understand all of them, for example, we may be a little bit remote from the term, but trust me when I say that it is everywhere. We just sometimes are not smart enough, or not, in my case, I speak for myself, of course, not even well versed in the glossary or terminology to even know that it is already there. In terms of, for example, let's just talk about predictive analysis. So everyone is just, statisticians or accountants used to just work with historical facts. But nowadays, there's greater demand or appetite for a bit of forecasting based on available data, and also data which is crunched by supercomputers, coming out with very specific, tailor-made set of data in order to come up with a certain predictive behavior, for example, demand for different types of ships, for example, which can really be zeroed in down to a very impressive rate of accuracy based on a number of ships which are being built, number of ships which are being sold, scrapped, and the demand for the cargo that they carry and so on. For example, ship owners, bankers alike can benefit from this kind of need. So it is already there. Except that I didn't know that it was called predictive analysis. I thought it was called Nujum Pak Belalang or guesstimate or whatever it is. And then of course, Internet of Things, cloud computing, everything is there, really. Creating new disruptions, creating new jobs. Blockchain, for example, something which is causing a lot of CFOs sleepless nights because they feel that one day their job will be replaced. Because with blockchain technologies, online transaction, the accounting part of it can just be done by computers, which will not complain about having to stay back late and mata berair bila buat kerja, down to 100% degree of accuracy. In fact, there are some low and middle level vocations or jobs which are already being done by computers. We all know about the advent made in telemedicine, for example. Kan? IBM has developed some kind of artificial intelligence to even do some legal work. Wow, this is good news. Lawyers will be out of jobs. They won't be able to extract money from us. So these sort of things are already happening. Even some kind of advisory in terms of medicine. I think a lot of things are happening within the tele-medicine, which I think warrants some kind of introspection, because I believe that in one of the services sector which is ripe for IR 4.0 in this country is telemedicine, actually.
Sorry, Cik Nazri, I
Yep.
have about 5 minutes left.
5 minutes, I have
Okay.
50 more slides, don't worry. I'll cover them very quickly. So in the marine industry, you can see lah, banyak macam the utilization in terms of use of information, some prototype of crewless ships is already out there. Some ada jadi, tak jadi tu, that's besides the point. But the fact that the technology is already there and people within the marine industry is bold enough to use it. In shipbuilding, people already sharing designs of ships between naval arcs, dengan ship owners, dengan shipyards, in a cloud environment, exchanging back and forth, doing some changes on CAD, which all can be shared in a virtual environment. MIS and so many other things like UAVs, vessel tracking management system in shipping, cybersecurity, which is one of the major enablers within the IRR context, and also big data analytics. So it's out there, it's already being done. To not on, obviously to a different extent here in Malaysia, because kita punya shipbuilding, ship repair is not, of course it is fairly sophisticated, is what Tan Sri already mentioned, because some of the yards do make sophisticated vessels, tapi in general, of course tak boleh nak compare dengan the level of complexity and sophistication of major shipyards around the world, like in Korea, Japan dan sebagainya. So this gives a lot of opportunities. We mentioned about collaboration, increase in efficiency, productivity, competitive advantage, and also better decision making, and which means in general better allocation of resources, because resources are scarce these days, especially financial resources. So companies really need to make very sharp decision to a high degree of accuracy, so they don't waste very valuable resources, especially when it comes to financing and so on. Because as we know, shipbuilding is a capex hungry business, so you need to get it right. And it also IR 4.0, as like they say, to balance things out, as many opportunities as they create, it also creates a lot of challenges, and some of them are being addressed by the components of the framework, which is mentioned by Puan Alia in terms of human capital, financing, regulatory framework, the need for education, training, and also learning, and also increase in awareness. Most importantly, something more abstract, which is mindset. Itu susah sekali nak tukar, kan? So, to conclude, I do believe that the Malaysian marine industry is ripe for changes. We can actually be at the forefront of changes within IR 4.0, and we can lead by example, because many activities within the shipbuilding, ship repair industry, and also to a certain extent, the entire marine supply chain is already being affected by IR 4.0, and there's a lot more opportunities for us to move up the value chain, to digitize, to immerse ourselves with the enabling technologies, and also increase our productivity and efficiency. In order to do things better, in order to produce better quality products and services at maybe a fraction of the cost which we are doing within the current brick and mortar approach, we need to unlearn, we need to relearn, we need to outlearn, we need to do everything with things, because otherwise we will run the risk of being left behind, or rather be immersed by this new technology, new revolution called IR 4.0. But what is needed is in terms of a framework, which I'm so glad that we already come up with, because I think rightly pointed out by Tan Sri Tajuddin juga, many of the industries now are having this realization, acknowledgement. Industries are all discussing about it within the context of the association, within the context of the ministries, lead agencies. Tapi they are not gelling, because, for example, in the marine industry, we cannot just be talking about the marine industry without taking into account other types of industries within ourselves. For example, in terms of Ministry of Commodities, Environment, technology, even finance part of it, human resource, and so on. So everything needs to be gel, and we can be happy that everything is not going to come up within a holistic, well-rounded framework, which is called the National Framework for IR 4.0. So whether you be disrupted or disrupt, or whether you embrace disruption or be disrupted. Thank you very much.
Thank you, Cik Nazri. We will now take a half an hour break. Therefore, we would like to invite all of you to the function room outside the auditorium for some refreshments. Please be reminded that our second session will start at approximately 11 o'clock. Thank you.
nanti ni start daripada sini. So tu je. Oh, daripada start pada sini lah. Saya yang akan kontrol dia. Nanti cik, nanti diorang akan ni, cik terus masuk Chrome je lah. Nanti Chrome, nanti cik dah ni, saya dekat sana, saya tengok cik nanti.
Bila masuknya dia boleh masuk, nanti saya akan masuk saya.
Password tu time bila? Time dah project ke atau apa?
Tak, sebab saya nak biar dia nampak.
Biar dia nampak.
Nampak benda ni, and then saya
Time
akan-
password tu dah nak masuk password semua, time dia nampak.
biar dia nampak saya masuk. Biar dia nampak benda dia.
So cik dah buka ni, tak pun cik hint saya ke, bagi signal saya macam ni ke, kesukaan projek lah.
Tak, biar nampak ni lah. Nampak ni. Nanti bila dia nampak tu, biar dia nampak yang saya inginkan saya masuk.
Yelah. Tak kira macam cik dah masuk Chrome ni nanti.
Oh, nak ubah daripada yang page dia kepada page saya.
Cik bagi signal kat saya tu, dekat thumbs up ke apa ke. Saya ada je dalam bilik. Okay.
side lah.
I nanti memang sebab I punya bateri is not functioning. Okay, I memang try dari sini kan. I tak tahu lah nanti duduk mana.
Duduk sini juga. Duduk main press lah. Nanti bila time sampai keluar sini.
Okay. No.
Sama ini lah.
Sama ini ya.
Okay.
Oh, later when it's my time, I will turun lah.
Saya tengok boleh berfungsi tak? You need the power supply kan?
Ya, ada nanti.
Mana sini kan?
Ada wire nanti.
Oh ya, ada mana?
Bateri mana sebabnya?
Apa tarik bawah sana? Panjang tak kabel ni panjang tak?
Kabel I panjang, cuma
panjang.
kena slow tap ataupun dekat sana terus. Yesterday I take from there, yang bawah tu.
Ini pun ada yang bawah.
Bawah tu ada.
Okey lah. Okey lah, kita cuba try dulu. Oh, kita ada supply lah.
Itu dia. Okay. Try video.
Tak ada nama sikit. Tu yang bahagian ini daripada yang betul masuk yang ini kita buka dia punya speaker.
Yang macam semalam tu.
Ah.
Apa ya? Sebab dah guna laptop ni kan.
Macam lain-lain program.
Cuba try
Dia
dulu.
bukan dalam PowerPoint yang ni.
Try.
Sebab dia keluar kat screen. Yang semalam kita kata dia kita tahu dia buat apa. Tak boleh apa. Tu video tu pun ada tu. Kita orang switch screen kan. Ambil sini tu. Ini tu ada video tu. Dia tengok dalam dia tu. Tunjuk tu dulu. Jadi dua video tu.
Yang jadi dua window tu lah.
Buka yang video pertama.
Ada movie sebenarnya. Dia bergerak nanti dia lambat sikit bergerak. Ya. Ya, kena buka sekali lagi. Kena komen.
Ada sini. Dia tu window dia.
Ya. Jadi yang ini kena tutup lah.
Boleh, boleh, boleh. No, no. Okay, so yang present just cabut je lah. Just unplug lah. Dan ni dalam oh,
But when it is finished, you need to remind me to take back iPad. You adjust lah, you don't adjust. Letak mana bagus.
Tadi sementara je.
macam mana pun
Dia letak dalam kotak tu lah. Tapi sekarang kena set up bagus-bagus dulu kan. So nanti akan tolong set up kan.
so just ambil HDMI tu tunjuk ni kan boleh
Later once it's finished, follow up. Sebab yang saya bring ni, ya. Kalau there's no other attachment.
Dia ada ah.
Syah, ni Faizal ni. Dia dah habis apa semua kan. Dia dah habis sampai slide berapa. Oh, terus buka ni je. Dah. Chrome kan? Dah. Chrome ni dia nak macam ni. Tu je. Terus sekarang.
Welcome back. Now we will continue our session with more presentations, of which our presenters will deep dive further into matters on human capital aspects as well as the technology sector. Our next presenter, Dr. Ahmad Faisal Muhammad Ayub, Senior Lecturer at University Malaysia Terengganu, will talk on the topic of strive to survive in the era of fourth IR. Dr. Ahmad Faisal, please welcome.
So, Bismillahirrahmanirrahim. Assalamualaikum and a very good morning. Thank you, Mr. Megat, for the introduction. I would like to thank all of you in the audience in this room. I've seen lots of my friends and lots of my teachers here. We have Datuk Murad over there. Segan rasa kat sini. Okay, so the second session is mostly on the technical aspect on what we do that relates to IR 4.0. And we've seen that the first part is mostly on the policy on how the bigger parts of the industry look at Industry 4.0. So the second one is mostly related to this one, my slide is mostly on the university side on how we implemented it. And there are some sharing that I would like to address. And my topic is mostly related to artificial intelligence and also autonomous vehicles. In my group, we are doing autonomous ground vehicle, autonomous aerial vehicle, and also autonomous spacecraft. So there might something that be something that you might be able to bring home afterwards. If there is one thing, if there is one takeaway that I would like to have the audience to bring home today, is mostly the autonomous part, the autonomous vehicles is in very infancy level. Okay. So let me try to browse through. Okay, once upon a time, 2,500 before century, in order to build one structure, a big structure, you need to have 100,000 men working to build only one structure. But if you see, if Klaus Schwab say that the Industrial Revolution start in 2015, or the Germans say that Industrial Revolution 4.0 start in 2012, we can see that few years after Industrial Revolution, only one man, one machine, they can build modular structures that build houses. So in this sense, we see that in order to build one big structure, you don't necessarily need to have you don't necessarily to have not big number of people. So this is something that we need to embrace. For the group that do artificial intelligence, for the group that do autonomous vehicles, for the group that do automation in design, for us, we are a little bit worried as well, because yesterday, we tried to do some modification on our setup. A 4-hour simulation that normally takes about 4 to 1 week. When we do some modification on the artificial intelligence, it reduced to 90 seconds. So that is something that really worries me as a researcher as well, because we are in the brink of looking at the computers to take charge of our work. So this is something that has been said again and again this morning, the definition of fourth industrial revolution. But one thing that I would like to have the audience to take home is the way we think and how we shift it. So basically, Industrial Revolution 4.0 will going to change the way we work, the way we live, and the way we relate to each other. I would like to bring one example for artificial intelligence that might relate to you. If you browse through Google and you leave your browsing history there, I know some of you would like to have clear the browser history because you are using public computer. Some of your browsing history are different than your friend's browsing history, because the browsing history is going to be fed to Google server, being trained, and Google will going to predict what you are going to search next. For example, if I'm here in Selangor, for example, in Cyberjaya, when I search pyramid in Google, it will show Sunway Pyramid. But if you are in Egypt, when you search pyramid, it will show you the pyramid. So these are all the custom. Google actually have the model of yourself in the server. The more you give information to Google, the more they can predict who you are and what are going to be your need for the future. For the single people, Google will going to match you with your future partners, for example. For us, the people who are getting aging, Google will going to predict based on what we need. for our health. So be aware that our data is being processed and being used as a prediction. So these are basically what happened in the Industrial Revolution. I'm going to link it with a story. If we take Industrial Revolution before the start of 1800, during that time, people are doing lots of farming. Okay, ada ramai farmers at situ. And then when you ask people, what do you want to do when you grow up? And the kids will say, okay, I want to be a farmer like my father. If the person who say that can live long enough until today, from 1850 to 2010, he will observe that the market to work as a farmer is no longer there yet. For example, in 1850, 50% of the population, this is the US data, probably you can relate it to Malaysia data as well, probably different sector. In 1850, 50% of the population are working as a farmer. And if the generation live long enough, they will start to realize that in 2012, only 2% or 10% of people in the US, the population, are working as farmers. This is due to the capability that has been unlocked by the technology. So we say that if you have one farmer and you can produce 1 unit of food, when the machine takes over, you can have one farmer to produce 10 units of foods. So what happened to the other 9 farmers? So they need to move to the other sectors. Probably in this case, we can see the services can maintain because all those machines need to be serviced. So in this sense, I would like to echo back what Ms. Alia said. The key is to be flexible. We need to move from one sector to the other sector and try to have our students to be ready on what we're going to change in the future. So in Fourth Industrial Revolution, one of the key megatrends that has been discussed by the World Economic Forum is the maritime industries. So because of the world is mostly covered by water, and then 40% of the water is a free water, the place that cannot be claimed by any countries. So maritime industry is big, and the boundary between the physical and also the digital aspect is going to diminish very, very soon. And this boundary is basically when you say if you want to pilot a boat or if you want to pilot a container ship, normally we use humans. But the most regulated industry, for example, aerospace, they have been doing autonomous flight for a long time. I'm sure you know that when a pilot tries to pilot an aircraft, he's piloting mostly for the takeoff and landing. During the operation, 4 hours of flight, the system is being controlled by autonomous system. But that autonomous system is not necessarily artificial intelligence because it only uses GPS and some algorithms to make sure that they arrive at a very accurate point. So in the future, when the Europe agreed to have full autonomous using artificial intelligence, the pilots are going to get worried. But bear in mind, the autonomous system atau autonomous technology is in a very infant stage. In March itself, last month, there are 2 cases on accidents involving autonomous cars. I believe you remember the first week of March, the cyclist being hit by Uber driver. I'm sure you've seen the case, you see the video. And last 2 weeks ago, there is another case involved the autonomous driver, the Tesla car. Only one person involved. The Apple engineer, he died due to the crash on the road. So Tesla said that this crash due to autonomous vehicle is not due to the autonomous system. This is due to the human error. They can put the press statement that favors themselves. And they put that to protect themselves in the manual, saying that an autonomous driver should not take their hands off from the steering for more than 6 seconds. So that's one of the things that protect Tesla nowadays. And the Apple engineer, despite of the warnings that came from the car, they sense some of the irregularity of the road, and then the car gives some blinking and physical signals, yet the driver has not put the hands on the steering. Hence, accidents happen, so collided with the road. when we talk to industries that involve with the automobile industries, we try to get some response because our group is doing autonomous vehicles and try to see what part of the academic can go into the industry. One of the comments they have is, for example, if you have heard PID, that's basically a very classical method of control. They said that they favor PID more than artificial intelligence. I asked why? Because PID is very robust. In what sense PID is robust? I asked. PID is robust because when you set your autonomous system here in Malaysia and you brought that autonomous system to Europe, it's going to follow the same thing, follow the coordinate, follow the route. However, for artificial intelligence that relies on visual cues using convolutional neural network, it tries to train based on Malaysia's route. And then when you go to Europe, you need to train it using European route. Same thing happens in inland transportation. When our group would want to do inland transportation, artificial neural network control, that control the vehicle need to be trained in Malaysia water and also being trained in European water. We cannot have things that as robust as the GPS or as robust as the PID. So those are the questions that we need to address to make sure that industry become confident on what we are developing in university. So these are some of the trends that we're going to bridge between physical and digital. We know that Industrial Revolution 4.0 will going to take out the barriers between physical and digital. When you say industrial, people keep talking about Internet of Things. Basically, the one that Mr. Nazri mentioned just now, the Internet of Things, probably it has been there for a long time. Yes, indeed, because initially, classically, when we go to the bank, we want to withdraw money, we go to the counter, and we need to talk to the people. And then you take out the physical money. So one of the example of classical Internet of Things is the ATM machine. It has been well connected throughout the world, throughout Malaysia. So when for us from the academic, we try to get the inspiration based from the ATM machines. What if we take this autonomy or the communication between devices as robust as the ATM machine? So there must be a solid regulation that control the Internet of Things. That's something we need to comment to the policymakers. Nowadays, if you go to anywhere, pergi kat McDonald's ke, you don't have to take out your cash. You just tap your Wave card and then the transaction being done. You get the food, but you didn't put any physical money. So these are kind of Internet of Things. Later, the Internet of Things are your cameras, the Wi-Fi cameras at home that transmitting signals to your, transmitting images to your phone saying that there is an intruder at your home, or people who are trying to monitor their babies at home without themselves being there. So these are the things that we need to change, and we need to try to adapt ourselves and try to put this into how we manage people in the industry. So the major drive, if I try to talk on my point of view from the group of artificial intelligence, the major drive is based on the massive, the availability of massive amount of data, and also the increasing computational power. Remember, the 4-hour simulation can reduce up to 90 minutes once we tweak something inside of the computational through using the artificial neural network. And then automated discoveries of new knowledge using artificial intelligence. Before this, when you try to teach computers to play chess, you need to define all those rules inside the chess playing. So nowadays, you don't need to program all those rules. You just take all the data and history, feed it into the artificial neural network, and it tries to beat you in the game of chess. So, and then later is the faster digital physical object creation. Nowadays, if you want to create 3D printing object, you don't have to own a 3D printer. You just go to Shapeways, and then you send your model, and it's being printed there. And I believe in Malaysia, there are 1 or 2 companies that work like this. They receive order on the drawings, and then straight away, we're going to create a 3D printing model. So it's much faster now, and we need to be careful on how to regulate this and to make sure that we can work together with the machines. Not in a sense that we want to replace the number of humans, no. But the use of artificial intelligence is to make sure that we can work more efficiently. For example, one designer, okay, the next slide, okay. one designer and one computer can create millions of design candidates. So I've been working on ship design using artificial intelligence from 2008, now 2018. So I think almost 10 years I've been working on this. So we made a system using generative algorithm. You do hull design using evolution algorithm. We have, for example, you have one designer and then one system, and at one click, your system will going to create millions of design candidates. And like Mr. Nazri said just now, probably the discovery of better hull design can be made using artificial intelligence, and it's a reality nowadays. So given the customer requirements, please explore the design to finally come out with hull design with 10% less fuel consumption, for example, if fuel consumption is your concern, while maintaining load characteristics and stability. So these are one of the case study. The method is using automation within the computers, virtual design. I believe MTCS is going to talk about virtual design afterwards. And also performance characteristic evaluation and artificial intelligence to explore the design space. So in 2008, when I tried to run, it takes about 2 weeks to create millions of design candidates. Nowadays, no longer. So within few hours, we can create millions of design candidates. That's one of the blessings of increasing computational power. Next, I moved to, once I am satisfied with the system, I moved to the physical part. So our group embarked on the rapid prototyping because finally we want to arrive to the creation of autonomous vehicles. But remember, again, we are in a university. We don't have much funding to build a ship as huge as what we have, which is RV Discovery. But we try to go to prove the concept using miniature vehicles. So in this particular case study in 2012-2016, we try to move towards rapid prototyping, one designer, one 3D printer, and couple of off-the-shelf parts. We want to create autonomous vehicles. So the phase one is to use rapid prototyping to model different models of quadcopters. This one is in 2012. So in 2012, the quadcopter communities has just, the drone community has just trying to emerge themselves. This is due to the democratization of systems. I believe everybody in this room have heard about open source. So one of the best things about open source is we can use whatever people has published, and we just need to acknowledge them and then try to republish it while acknowledging who are the main, the first people who write it. So we open source the design, and then once I understand the complexity of quadcopter, I think that, okay, once we have known what are the key characteristics of a drone, we can simply move all the system to the ground vehicle and also the surface vehicle. So ultimately, when I finished doing this in 2014, I settled in the surface vehicle. I settled with the PID only. So I believe last 2 weeks ago, when I was convinced that the convolutional neural network, the visual-based neural network is the future, I was going to push this autonomous vehicle not only to limit to the PID only, not only limit on the GPS, but you are going to put a camera in front of your ship, and then just tell the vehicle to move from coordinate, and it will going to use the camera to move the vehicle. If there is an obstacle, it tries to move itself. So less dependency on the sensors, and we create redundancy, which is a good thing. Redundancy is very important in autonomous vehicles. So we have learned some lessons. Okay, lesson learn number one: the truly autonomous vehicles, taking into account what happened during March last month. Truly autonomous vehicle technologies in marine vehicles is really in baby stage. Nonetheless, now is the best time to invest the effort to nurture these autonomous vehicles, because the one who pioneered it will going to create a snowball. So that's what I think, because I remember most of the seafoods in this room are mostly pioneers in shipbuilding, and I believe this is some minor part that I contribute to the ship design and shipbuilding. And these are the types of autonomous vehicle that initially they have GPS and radar, and then next the usage of artificial neural network, and then next the hybrid that we create redundancy. So this is, I made this slide before the second accident happened. The last week of March happened the second accident of autonomous vehicle. So please remember, autonomous vehicle is still in infancy stage, and for us in university, we try to invest our effort to contribute this to the industry. And these are some of the example. Okay, nowadays people are using man-shipped, and then the general alternative is to use the remote ship and automated ship. This is not yet autonomous because the ship is going to only depend on the satellite. Later is autonomous ship, where the ship intelligently try to decide based on the radar, based on what they have trained, the autonomous system has been trained, and try to decide which sensors that can be used to search for threats or obstacles. One of the real-world project is the effort from the Europeans, Advanced Autonomous Waterborne Application, AAWA partners. This is pursued by the Rolls-Royce, and they also have made the roadmap. So basically, in 2020 itself, the autonomous vehicle is not going, the autonomous ship will not going to be stabilized. So based from their roadmap. But given people roadmap, we can pursue our own roadmap. So this is the clue from the Europes. And the European are really comfortable on deploying their truly autonomous vehicle only in 2035. So these are something that we think can take the cues from the Europes. Lesson number 2. There are 3 aspects in embracing Industrial Revolution 4.0.
Sorry, Dr. Ahmad, we have 5 minutes left.
Yes. Closing. Thank you. Okay. First, we are able to reduce the headcounts with the employment of intelligent systems. And also, second strategy is to maintain the headcounts while achieving more. Remember the farmer's story. We have one farmer to create 1 unit of food, and then later the one farmer can create 10 units of food. Similarly for us, the designer, one designer can now create millions of design, and we can propose better and better design in the future. And nowadays, artificial intelligence has become very cheaper in terms of computational power. If you have computers, the one on your laptop, that can also be used to run artificial intelligence modeling. So for the designer like ourselves, we can easily go mobile with the very powerful things that we have in our pockets and our bags. So no longer use the workstation or HPC, high performance computing. So physical shipbuilding may take a while to move due to the cost and ROI, I understand. But bear in mind, this is something that we need to take into account, because anyhow, you need to try to predict what kind of resources that you need to put in the warehouse. If you have a data on 1 year, what are the things that you bought and then not used inside your warehouse? Please bear in mind, you can predict what are kind of things that you need on January, February, March, April, depending on the seasons. For example, after monsoon season, there are going to be a lot of maintenance. So that's, you are not necessarily need to stack up all those components inside your warehouse and deliver fast solution through artificial intelligence. So these are the things that I can summarize. Moving forward for academia in artificial intelligence, unmanned vessel will start with local operations. No seagoing operation will go for the unmanned system, because this is very dangerous. Sea is very open. There are risks of losing your vehicles. So normally, naturally our group will going to focus on inland operation, low risk operation, inland transport, low traffic, small size, and the unmanned operation will not going to start with hardware development, but it start with creating the brain from the ship first. So this is the thing that we are doing. And one thing that I would like to emphasize, the applied artificial intelligence is the future. So for us, between academia and also industry, let's look into this together. And if you would like to talk about artificial intelligence and its application, I'm volunteering to be your guy. Thank you so much.
Thank you, Dr. Ahmad. Now let us welcome Mr. Nur Ashar Abu Rashid from Berry Veritas to talk about project management tools for Industry 4.0. Floor is yours.
Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to all participants and fellow speakers. Today I would like to share with you the existing tools that we have been using by BV, which we call Veristar PM Project Management. And for today's presentation, I would like to take a different approach by not utilizing normal PowerPoint, but using the actual software that we are using now. The software that we are using, which we call Veristar Project Management, had been started in, I think, around 2004 when I first joined BV. It was introduced to our surveyors on a voluntary basis, where based on the feedbacks that they received from that time, it has been evolved into what we have now. This system has been made compulsory for our projects since 2011. By using this system, actually, this is a real-time application for all the projects that BV are having now. Each projects are individualized according to types of ships, and according to the different rules and regulations applicable for each ship. So I will show you now first one of the ships that we just recently delivered in a local shipyard. Okay, in our system, it consists of 5 elements. Project general data, design review, product certification, survey at shipbuilder, or what we call it survey at yard, and the last element is the in-service. For this ship, the in-service is there because the ship is already in operation. Let me go through with you one key elements one by one. Here, the first. Okay, what we call a tree is actually a list of items that is typical in a new construction projects. And we have a link with a GA that is being produced. For this, at the moment, it is still being used manually because, as I said before, for each project, it is being created according to the actual projects, according to the specific, for example, GA or typical for that particular vessel. So this is being produced based on the actual ship. Okay, so here we have this what we call a tree, where we can expand our activities and list of interventions for the surveyors. But at the same time, from the graphics that we have here, we can identify for each activity between this graphic to the link of the tree. So here you can see the color, it is color coded, but for this project you can see only green because it's completed. It's like using the traffic light system, red, green and yellow or amber. So for each project we have identified by unique BV register number, the name of the vessel, and the shipbuilder. We have identification of all the ship of the relevant shipbuilder, and then using the tool, it is identified on what are the specific for rules and regulation for the vessel, what are the owners, and then we have a class data which identify what are the service notations or what is the type of vessels of the projects, showing the service notation, the type of service, additional service notation, navigation notation, and so on. And here it would identify if the vessel has a sister vessel with the same project. And we have a list here, what are the relevant statutory for the vessel. And in here, what we call actor is actually those who are involved. For this project, again, for the BV context, it doesn't appear because for each completed project, those who are involved or were assigned for the projects were revoked about 2 weeks after the vessel is delivered. The reason for this is for each project, each actor are being appointed by the new construction manager, and then only those who are involved or assigned for the project can have a look at this system. That goes also for the external contacts, which are the owner, ship owner, or designer, in order to ensure the IP rights are kept within control. For each project, these are linked to several parties, namely the suppliers, designers, and shipyards. And we keep track of the progress of the projects by having what we call calendar. And that's the first element. The second element is on the design aspect or the plan approval, design review. Here we have the list of all the list of all the drawings, percentage of comments, and so on. And here also it is being color coded. Green means that it has been completed. For items that is being under review or being re-submitted, will be different color coded. We have a checklist of all the items, and the number of drawings received all can be reviewed directly from the system. We have okay, for this I apologize because this since it has been revoked, I cannot open. I would have to open other drawings. Okay. The third element is called product certification. What it shows is actually the list of equipments with all the relevant certificates, and also the manufacturer involved. For example, for this hydraulic cylinder jack, here we'll see the actual certificate that was issued for that particular vessel. But for this feature, it is only for linked projects or actual certificates that are assigned for that specific projects. This is to ensure that the items that is being delivered at the shipyard and the certificate that is being issued at the shipyard tallies with what we have in our records. So in here, the links goes to the tree that we saw just now, on where the items are in the projects. also in here are the list of comments during the projects for the items or during the construction or fabrication of the items to the clients, ship owners, which we call My Very Star. Demonstration will be given by my colleagues outside, Mr. Tamizi. For those who are interested, you can see the application of this VPM outside as well, to see how it actually blends with our work within all the relevant parties. And for the apps, you can see especially for ship owners, you can see how this can be used by all of you on a real-time basis. Thank you.
Thank you, Encik Razak. To speak on the application of VR technology in ship design and production, please welcome Mr. Abdul Razak Ismail, the Managing Director of MTCMS Design Sdn Bhd. Ladies and gentlemen, please welcome.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And very good morning, Tan Sri, Datuk, and to the audience. Actually, I have a very big challenge here. While being this being set up, the challenge is I have to keep to the time given. I used to deliver only 10 slides, and it took me 1 hour. Now I have about 29 slides. I have to do it in 20 minutes. So that's a challenge for me. Anyway, well, I think we have listened to the various speakers talking about the application of I4 in shipbuilding and ship repair industry in the local market especially. Yeah. So my paper, or the title of my presentation is Application of Virtual Reality Technology in Ship Design and Production or Construction. You may like it to be that way. So the focus is more on the local industry. I'm not going to talk about what has happened outside Malaysia in the world, because in my course, to jual ubat to the local market with respect to this VR technology, the response mostly will say, well, other countries can do it, no problem, USA, Korea, or Germany. Malaysia boleh, but in this case, I think we are not ready. Only last 2 months, or less than 2 months ago, at MITI program, the speakers say, no, in our opinion, we are not even in industry 2, so how can we go to industry 4? Yeah. One say, oh, we are not even in industry 3, so how can we go to industry 4? So I hope for the whole morning, this morning, I think you have seen what has been presented by the other speakers. Are you ready for industry 4? Oh, sorry. I'm not used to industry 4 myself. Just to set up this thing, can I use this one? No. Okay. All right, just a little bit of where we come from, the companies. MTCMS, actually a joint venture of 2 companies. MTC Floating Solution and Mega Salute Ship Design Sdn Bhd. It's a Bumi Putra company formed only last year in September. MTCFS is already known in the market in the oil and gas industry as a pioneer in the hummingbird offshore solution. It's a trademark of MTC Group of company, in hummingbird offshore solution, and it's now being copied by our competitors. No problem. Imitation is a flattery, I have to say. Yeah. And MS, Mega Salute, is a pioneer in 3D ship design in the region. These 2 companies are homegrown companies. No blue eyes except for the contact lens, maybe they wear contact lens. Yeah. And no blonde hair except white hair like me. So these are all fully homegrown companies. So Malaysia boleh. Yeah. Oh. Not moving. I need help now. Why not moving? Any IT guy? Why not moving? Tak gerak, tak gerak. Oh, kena tekan situ. Oh, okay. Okay lah. So we have to abandon i4 technology first. So we use this one, next one. Okay. This is the latest achievement from MTC Group of Company, where we are the winner of Petronas Technology Challenge 2017, beating 33 other competitors from 10 countries worldwide. Of course, this is now being developed. Yeah, just to highlight. Why I mention this one is just to put the attention to the local people, especially that local people are capable of beating the others at the world stage. Just give the chance. I know some of you agree with me on that point. We are not given enough chance, I think. Yeah? Okay, this is what we do. We apply advanced design philosophy in our work using cutting-edge technology, and we desire to innovate, to be at the forefront. We have to be innovative. And we're doing now, we are providing disruptive innovation. What I'm going to show you later on actually is disruptive innovation or solution, which is very hard to sell in the first place anyway. It's a challenge. And we provide solution to the ship owner, to the industry player, from the beginning of the design until the end of the ship life. This is the new approach in ship design. Okay, this one maybe just I put this before I heard the papers from the other speakers. Perhaps now these are all not relevant anymore. I think you got the answer. But just to highlight that what happened at the local market, we are about 15% according to my report. You have the report with you now, I think each one of you. On page, I can't remember what page number in the early part, it says 15% of the shipyards in Malaysia at medium level of automation. Yeah. So talking about, if you are not in that, just now I think I saw a paper from Dr. Faisal about is shipbuilding industry ready, even at industry 3, yeah, in one of the sites just now. Well, my point here is that I put there at the bottom 68% automation. Samsung Heavy Industries, being the most advanced shipbuilders in the world, only at 68% automation. They're not even 100%. So you're waiting for 100%, maybe you wait until the cow come home, maybe. Yeah, will never happen. So let's say, forget about industry 2, industry 3, let's go for industry 4. Why? Our earlier speakers have mentioned about the benefit, being increase our competitiveness. All right, just look at the scenario of our local industry. Just 2 lines only I put there. Our local SBSR scenario, lacking in competitiveness. Well, some of you may want to challenge my point, but I think this is my view. I can support my view. And in the last, lacking competitiveness, why? Because local owner would prefer to build outside Malaysia, China, for example. Why? Because our cost is 20% more expensive. If I'm the owner, I'm not going to build locally. Why should I pay 20% more when I can get much less outside? Yeah? Not to mention about delivery, quality and whatnot. And one more thing I just want to highlight to the audience also, for those who are not from the SBSR industry, for the past 35 years since I've been working, there's no major technological change as far as the local industry is concerned. Another point to be challenged, I would say, but I stand to be corrected. Maybe we have moved from manual cutting to automatic cutting, yes, CNC, as mentioned by our speakers earlier. Yeah? When we have auto blast shop, other than that, welding, we still use the same SAW, semi-automatic machine for long welding, horizontal plate welding. We still use the same MIG, still use the SAW technique. So I don't see any much progress as far as technology is concerned. Yeah, adaptation of automation, of course, is far from, not, I don't see any in the industry, yeah. I stand to be corrected though. So I see I4 as a game changer. As a game changer that really can make our local industry to be at par with the world industry players. In my quick search on Google, nobody can run from Google nowadays. As far as virtual reality is concerned, we are just about 2 years behind, or maybe less, compared to 35 years when it comes to automation. Yeah? So Industry 4 is good for us, for small player, for small country, because the capital outlay is much, much less than automation robotic. Because I think I4 is all about data. Correct me if I'm wrong. Eh? It's about digitalization. It's all about data, sharing of data, using of data, transmit of data, using sensors, all this IoT and whatnot. I mean, beside the rest of it, the hardware. So there's no, we're not going back. We are going to go to I4. But my slide is not moving forward. Okay. Just for a quick one, I'll give you why we are not competitive. The CBSR, these are the issues. I would say whenever we attend forum in the country for the past 10 years or even 20 years ago, this is the same thing, never change. High cost of production, about 20 to 30% more. Wastage is high, between 15 to 25%. Productivity is low. This is general. I would say maybe there are some yard may be better than this. This is just in general. Yeah, productivity is low because a lot of clashes. You know what clashes? No, when you in the ship there are many systems. You have piping system. We have even piping system. There can be up to 10 piping system. And then we have the electrical cable tray, the HVAC for the aircon, the structure or whatnot. When you design in 2D, these things tend to get clashed. No matter how experienced the designer is, how experienced the builder is. We cannot imagine in 3D so much. Okay, virtual reality is not there. So this is normal. When I was doing last time, the rework part or the repair is easily between 20 to 30%. Production delay is the norm. Maybe 1 or 2 years is Malaysia is able to provide on time or ahead. But the rest they say all delay. Quality, of course, we can improve on that. So what I'm saying is, what if all that can be improved? Production time can be reduced by 50%. Instead of 2 years, we can do it in 1 year. Steel wastage is capped at 6% instead of 15%. Typo there actually, not reduction, actually 6%. Of course, we cannot eliminate wastage at all, totally, yeah? At least about 5%, 6%. Quality improved, delivery time will be much earlier than what's specified in the contract, and overall cost saving about 20%. Don't you think we can beat China now? So this Industry 4 can provide this. I'm a strong believer in Industry 4 now, okay? And I hope all of you also, when you get out from this meeting today, you'll become the advocates of Industry 4 for SBSR in Malaysia. I hope. Join me in the Industry 4 group for SBSR. Just want to share with you what we do is advanced design philosophy. We call it MTCMS design philosophy. The top part is the traditional or conventional one, this one. Where designers start with 2D, they may use AutoCAD or whatnot, computer software, but still in 2D, they print it in 2D, you cannot see in 3 dimensions. And the detail design also is in 2D. And then mostly stop here. Hardly we go beyond that. I know now there are attempts to do it locally. As far as the world is concerned, 3D is nothing new. Yeah. So what we do here is talking about our philosophy. We start with 3D. We reverse the process. So this is a game changer for us for the design part. If I can use the word, somebody mentioned Uberize the taxi industry. Uber has changed the taxi industry. We want to change the SBSR industry by applying design backwards. The beauty, the benefit is tremendous. I show you the next slide. Yeah, Just understand about the process. Now we reverse, yeah. So when we reverse the process, we try to sell the idea to the industry player. It's hard to imagine. You cannot imagine because we are still in the old frame. See, it's quite a challenge there. Anyway, things going to change soon, inshallah. So when we say 3D, this is what we produce. The designer. I think I skipped one slide earlier on. I think it's just about illustration. Never mind, it's not important. So this is the production design that we do for a particular ship. Everything is inside there. All this color means different system. So we build the ship in the computer, yeah, in virtual reality. So we are able to check whether the piping is to clash with the electrical cable tray, with the structure, or not. It's all being done here at this stage. The steel it's not been cut yet at the yard. We built the ship first here. Any changes is at a minimum cost. For the moment, we offer free of charge. It's part of the scope. I'm going to bring you the next slide to walk through. Sorry, too fast. This is why we need high data, whatever, we need big data kind of thing, so that you move very fast. It's a bit slow. Just to show you, it's from actual project, and the ship has been completed. Just to show you, this is what we do before the ship has been built. We build the ship in the computer. We see what's inside the ship, the arrangement. This is an offshore, it's an anchor handling tug and support vessel. Yeah, 61.82 meter. The ship now ready in Sarawak. Yeah, it's all homegrown effort by the team. You can see all the tank for supply vessel. You can see the arrangement for the engine room here and the accommodation here. You can see the structure, the arrangement. By the way, when it comes to the structure, we use finite element analysis, another technology, to optimize the scantling. Still comply with class requirement. Yeah, in one project, we managed to reduce the steel weight by 300 tons. Depend on the size of the ship, of course. Yeah. So you can see, for the ship owner, they can use this as a training also. Even before they go on board, the crew can go through the ship by just looking at our virtual reality program. So if at this stage, if the owner is not happy with the arrangement, okay, we can rearrange, because this is where we can incorporate the design for operation, not just design for production, design for operation. If you don't like the arrangement, yeah, the owner, the operator can say, okay, you want to rearrange. So you can see everything, the piping, the equipment. After this, we walk through the ship. So now, okay, the ship is completed now. Mr. Owner, please come with me. We go on board your ship. And look. You don't like the color, we change the color. For the piping, you can change the color of the piping according to the code of the company code. Labeling, this all can be done in virtual reality. So this is where the tank just now you saw in the earlier part. This vessel has about 15 piping systems, more than the normal ship because of the cargo. We have to carry cement, we have to carry brine, mud, yeah, for offshore operation. We can fuel cargo for offshore supply, for offshore use. So this is the arrangement in the engine room. Every equipment, every single item is in the precise place. There's no room for error. And looking at the piping system in the engine room, we want to open up this platform, you can see the pipe. There's no way that you can go easily. And there's a precision is there. No clashing whatsoever. And I will show later on, with this also, since the vessel already completed, when it comes to construction, you can use what we call it modular construction. You can see from here, manhole here, whether you block by the piping or not, you know, it's not going to block. But you look at 2D drawing, you have to start to imagine to match up the structural part and the piping. Very challenging. But now things is easy, yeah. Just like playing game. I was saying just now again, you can do in modular construction because everything is there. Modular construction has never been practiced in Malaysia. I stand to be corrected. Never been practiced in Malaysia, even though I studied that 40 years ago. So that's how far we are ahead of time or behind time. Yeah. But with this technology, you are able to do modular construction, and because of that, the construction time can be reduced. Next one is a bit challenging. Please help me. Sorry. What I'm going to show next is the software that we use. The software, this data is given to the ship owner and to the shipyard. It's interactive. Yeah. So, what we are showing here, sharing with you, actually is a real application. It's no more a classroom matter. Yeah, sorry, doctor, you are far ahead. You are in the doing the research part, but we are in the real thing. I come from the industry. We come from the group people who use technology for our benefit. So, next one, tukar dia punya tu, dia punya apa? Dia punya window tu. Tutup PowerPoint kat mana, saya pun tak faham. Tadi tak tahu nampak cuma. I know it's quite challenging for me even to use this one. It's quite challenging, but there's no way that you can escape. I wish we have a seamless transmission between the slide and
Boleh
this,
tutup yang ini.
software. Why we want to show this? We want to show that it's not a matter of something for relaxation, but it's the real thing. And just now, we showed the real software that they use for project management too. By the way, that software has been there for the past more than 50 years. So it shows that we are ready. Local players, local industry are ready for Industry 4. As you can see from here, we are going to select one item. This is the real ship. This is the one that you saw earlier, the video. Yeah. So now we are getting in the software where you can select one particular item. For example, then you can see what come out. This is the item. Every item is at your fingertip. For the surveyor, perhaps Monday you don't have to go on board and just use our system. Then you can just survey from here with your real-time reporting. I don't know. I'm just imagining things. So this one, the pipe, you have pipe there. This one pipe there. You select this pipe. See what come out. So you see the data for the pipe. So taking what when it comes to maintenance in the life of the ship, you have to do certain repair and maintenance. All you got to do to identify which one here, you know what comes out here. You can prefab that one before the vessel come to the yard for replacement. Okay. Oh, sorry. I never know that I'm being recorded. So now I know. That's why they want me to speak here. So just now the part that one censored, yeah? Okay, that one censored earlier. Okay, I think that's enough. We show this one because I don't want the MC start to remind me, you got 5 minutes. I promised you just now 3 hours, right? So 5 minutes is a bit too short for me. Okay, this is what we see now. Continue with the slide. Example of the piping, 3D piping layout. Oh, okay, now I can use this one. So a lot of piping there. I can use this now. And this example of the 2D drawing. This is 2D drawing where we used to see. And from the 3D, we can produce this. We reverse the process. Yeah? I mentioned earlier, we reverse the process from 3D to 2D. And just look at this, the details, the angle, inclination. Before this is, in the past, we don't have this. So whoever read the drawing, they have to imagine how this one look like. Now no need, show you. Okay, you get precise construction. So this is a spool arrangement for one of the system. This is the 3D ducting layout. And the next one is the assembly drawing for the structure. As I mentioned earlier on, you can do it in block. And this block, this is normal. Malaysia yard do this, block construction for the structure. But what we are seeing now with the 3D virtual reality technology, whatever is contained in this block can be pre-fitted, modular, like what Samsung is doing. I was fortunate to be in Korea, Samsung shipyard, about 15 years ago. I said, wow, this is what I've been looking for. The prefab or modular construction is complete for each block, everything in, even the propeller for the engine block. All they do is just join at the later stage in the dry dock, just the block join and the connection. It's an eye-opener. I think we can still go to Samsung and visit them, see how they do it. Yeah. So the same here. So this will shorten the production. Quality is ensured because we use 3D model, 3D design. Yeah. Don't compromise on quality. And talking about CNC cutting, yeah, this is what we have. But then pay for attention to the word optimize. When say optimize, just now Dr. Faisal mentioned that one designer can do, one computer can do millions of design. Yeah. So we use algorithm also to arrange the plate to make sure that wastage is kept to the minimum. That's why we can reduce wastage from 15% to only 6%. Yeah. So reduce cost saving there. Yeah, this is what we want to offer even extra from the traditional design. Inventory database to the ship owner, right? So everything prepared for them. No need to wait for the vessel to be completed. We can do it before the ship is being built. So with this, maintenance will be much easier. All the item given, listed. And of course, when you select on this item, you will come up with the detail. What is it for that particular item that you select? Okay, the proven outcome from using virtual reality technology in ship design and construction are these: reduce production time, reduce material wastage, increase productivity, better management system with the software and so on, information, ease of maintenance. I show you about the inventory just now. Improve quality, because quality now is being built into the system. No clashing of system. No clashing, no need to repair, no need to modify. So what does that mean? It means quality is improved. Right? Optimized design. We use fine element for scaling and exceptional performance. I'll show you later on also some technology that we use in the design process. So what we offer here, I have to use this one. Okay. All right, this is what we offer now. Traditionally, design house will provide up to here, production design, or even up to here would even have basic design. Production design, some shipyard will do themselves because they have the people. But some yard will ask the designer to do it, so they will stop here. In our case, of course, we can offer this, and most important is in our design, we give this inventory system, yeah, inventory database for hull, machinery, piping, all on board. That's the main difference from the 2D, yeah, as far as our deliverable, yeah, beside the drawing. Yeah, this is some tool that we use in coming up with the design. In this case, it's they're using CFD, computational fluid dynamics, where we can evaluate the performance of the hull form, okay, and then we can optimize. Just now, the professor mentioned about optimize the design. I think what 10% fuel saving while maintaining the payload and the stability, yeah. And then you can reduce your fuel consumption. How? Is by optimizing the hull form and the propulsion system, propeller and so on. Okay? So we do this in our design. In a way, this point, I want to highlight, it will change the way the government contract, sorry to say this, pay attention, the government contract call for tender. Nowadays, when you open up a tender document, you say that must be proven hull. Proven hull. Okay? In our case, this is how we prove our hull. That the speed can be achieved because we use technology. We use computer, tool, software, database, wide database, powerful computer. The CFD now, we need to have a supercomputer. I don't know, UMT, you have a supercomputer? No, we don't have. But in Cyberjaya, you know, one company has supercomputer to do this kind of analysis. So we are talking to them for that purpose. Of course, we have powerful visualization using this technology, and what more, the result is accurate, and the analysis can be very detailed. Yeah, you have, even now we are talking about, watch out the word, we would like to propose to use virtual towing tank instead of just the physical towing tank. UMT, take note, maybe you have budget for that. Yeah, we are so powerful now, the computer, the software, everything. So this is part of Industry 4. Another one. Another video, I know I can see some people start to sleep already.
Sorry, Teresa, you have another 5 minutes?
Oh dear. I thought I can manage to avoid that reminder, but I cannot. Okay, never mind. So this is to show you what we call it, the simulation that we do. One of the design that we're working on, sea state 3 simulation. Sea state 3 is talking about wave height up to 1.25 meter. That is the sea state, they call it. They have divided all this state, whatever. And then this is at speed of 12 knots. You can see the performance of the vessel. So even the vessel before it's been completed, we know what the performance is going to be like. Agak-agak mabuk tak? I don't think so, kot. Okay. So we stop this one. I think I have a problem. Why I go back there? I think I got problem here, yes. It's got confused now. Go to the video. How do I go back? Sorry, Mr. MC, I cannot go out now. I'm lost in the virtual world. Okay, maybe here. Okay. So this is an example of the finite element analysis that we do for some of the structure. Yeah. Here we can analyze the stress distribution and deformation and so on and so forth. It's quite common for the past, maybe 20 years or so. Nothing new. So what we are seeing now, local company is able to offer world-class ship design and shipbuilding capability. And it is the way forward for Industry 4. And we would like to be part of that enabler, player that can help make the local industry more competitive. This is the solution, Industry 4. I don't see any other solution. To be honest with you, one more minute. To be honest with you, since I was involved in Army for the past 10 years or so, whenever we have forum, people will say, hey, let's make make the government make a policy, rule, all local owner must build locally. You can ask Mr. Anwar, you can ask everybody here. This is the common always. And the owner said, how can we build locally when the price is so expensive? And I said to myself, yeah, we cannot be cruel to the ship owner. Just we want to protect one industry. So I have no answer. I had no answer. But today I have the answer. Industry 4. So that's the way forward. Thank you. Thank you very much.
Thank you, Chair. Now we have come to our last presenter, who will be talking about Industry 4.0 in Malaysia's SME practice. Mr. Sim Hon Wai is the Chief Operating Officer of MDT Innovations Sdn Bhd. Ladies and gentlemen, please welcome.
Well, good afternoon, distinguished guests, ladies and gentlemen. My name is Sim Hon Wai from MDT Innovations. Unfortunately, I'm standing between you and your lunch, trying to make it sweet and short, as sweet as candy, as short as miniskirt. Okay. So I'm coming from a company that focus on ourselves on IoT. So I think this has been much talked about topic earlier this morning, and I'm also humbled with some of the previous speakers about the content that they have shared. Very interesting and very enlightening. I wouldn't want to go into detail what will be Industry 4.0 like. Probably it has been much talked about by earlier presenters. But I think probably I'm obliged also to actually describe a little bit about where we're coming from, what my company is doing, so that you are aware that the capability and also the past records that we have. So like I said earlier, we call ourselves IoT enabler, the fact that we always believe in the philosophy of trying to connect things, trying to convert analog behavior into digital. So we are coming from embedded solution perspective, whereby we made hardware, we embed sensors, we turn the sensors and sense analog environment into digital data, and we build solutions and services on top of it. So the key areas that we look into are crowd management. We do a lot of people management, moving from point A to point B. It may or may not be relevant in the maritime industry, but we'll look into the case studies and see probably it may be applicable to your organization. Second part is things management. We do asset and fixture monitoring, as simple as your table and chairs, where they move, as important as whether your fixtures integrity is strong, whether they will collapse when there is an impact. So those are the things that we do. And of course, the third part we do is e-payment, which I'm not going to talk about it. It's irrelevant in for this topic. So financial snapshot perspective and general complete background, we have been established since 2004. We are not a new kid on the block. We have been in existence since quite some time, more than 10 years. We are probably the fastest growing tech company not only in Malaysia, in Asia Pacific. Evidently that we have a third-party validation by Deloitte Fast 500. We were award winner 2011. We ranked number 12 overall in Asia Pacific. As recent as last month in February, APAC CIO magazine, Outlook magazine, has selected us as one of the top 25 IoT companies in the world. So those are the third-party validations that we have, and of course a company that is profitable since day one. We are also enlightened to be featured by Gartner. If you Google Gartner, one of the renowned research institutions, we were featured in Gartner 2 years ago as one of the cool vendors in the technology of NFC. So not going to talk too much about the accolades that we have won, but if you look at the bottom part of the slides, we believe in IP, we believe in intellectual properties. we invest a lot in R&D, and we have filed about 38 IPs, filed and awarded 38 IPs. Not only in Malaysia, we have IPs throughout Asia Pac, including Australia, New Zealand, China, Japan, EU, as close as Singapore, Thailand, Bangladesh, India, and etc. And we believe in ability to convert analog behavior by putting in sensors and embedded solutions. That is where we are coming from. So having said that, it will be interesting to talk a little bit about the summary of Industry 4.0, or some call it Industry Revolution 4.0, the gist behind it. I'm not going to explain, from how it evolved from 1.0 to 4.0, but I think there are 8 key pillars that we may need to understand what is IRA 4.0. Of course, with the implementation of IRA 4.0, you have probably able to achieve interoperability. You have information transparency. You have a lot of technical assistance in your operation and businesses. You have decentralized decision making, so you don't have to come back to the MD or CEO for every decision that your organization have to make. But of course, the risks will always be there. There will be data security that will look into it. The last thing that you want is probably there are some man-in-the-middle attack taking over the identity of your items and also your control systems. Reliability issue, let's say you rely heavily on automation. Once it breaks down, it's going to be a total disaster. So those are the things that people have to actually look into it. Integrity of data, of course, when we say that we implement IoT in Industry 4.0, it's a very dependable data source that you can use to crunch and give you analytics, all right? Because you no longer have data entry clerk to enter data into a system. Of course, you need to ensure integrity of this data coming from the sensor so that it is highly dependable when you actually produce results in terms of analysis, whether it is descriptive analysis, telling you what is happening within your environment, which probably you may not have at this moment because most of the data are probably pretty manual. And now when you have sensors telling you what is actually happening, then you may look into probably predictive solutions, what you want to do. And of course, last thing is probably loss of jobs. Loss of jobs, there are pros and cons behind. Of course, with automation, tend to have people that will, especially operator level, will not be having the similar kind of activity anymore. But these are the people that you can retrain and actually probably elevate their knowledge in order to handle some other more intelligent stuffs. So these are the gist of Industry 4.0 that we always talk about. But then how Industry 4.0 and how IoT can be really applicable, I think for the past 15 years or even 20 years, it is much talked about and it is highly looked after, sought after, because the cost of connectivity has actually reduced quite a fair bit since probably 5 to 10 years. So now we have the Bluetooth, you have the Wi-Fi, you have the LoRa, you have the Sigfox, you have the NB-IoT, which does long range. Of course, so you can also fall back to traditional connectivity like GSM, as simple as 2G if you don't have a lot of data to send, or as complex as 3G and 4G, or probably upcoming 5G if you want to send huge loads of data from your operation back to the data centers. So the cost of connectivity has been pretty much lower. So what will be the stumbling block for IoT? So the next will be probably how you can actually implement the right technology, the right devices in order to turn your analog behavior into digital. So hence, in connecting manufacturing, that we always speak about how IoT will be able to help, and also how Industry 4.0 will be much talked about. We'll be able to actually do M2M health check. You look at this graph, machine-to-machine talking. I think Josh Lucas have actually shown us it is possible when R2D2 talk to CP3. Also, it's machine-to-machine. Of course, now we come to the actual world. You can actually connect from machine to machine by sharing information in order to actually understand better how you should actually promote or actually enhance your efficiency. And then, of course, not only the machines, you have to look into workplace safety, because the human resources are your assets. And of course, as simple as WMS, fleet management, JIT, material supply chain, work in progress, automation, those are the things that are possible and already been done with, by a lot of people, not only overseas. I'm seeing a lot of Malaysian private companies are actually investing into technology, into IoT, into Industry 4.0. So there are a few case studies that I will be able to share with you, and how it's describing how we make things connected. So of course, in every operation, you will have fundamental issues whereby things are very legacy. Okay, you have machines, you have systems that are not very connected. So I think that is the one thing that we come from. If you have a legacy machine, you cannot make your machine smarter. So that is how we come in. We always give you consultative approach in order to see what kind of sensors that we can embed in order to understand how your machine works. So for example, you have CNC machines, that actually, cut metal parts or plastic parts for you. So whether it is operating at the right temperature, it is actually cutting at the right angle, and then the arms that it moves, what kind of acceleration that it moves, it creates, and also the gyro, the tilt that it actually produces. So these are the things that we can bolt on sensors to actually try to understand. So with that, probably as simple as maintenance of your machines can be predicted, because, for example, the arm has been moved vigorously, and it is beyond, the specification produced by the manufacturer, the maker of the machine. So therefore, probably you need to predict this one will be down, or probably will need to be repaired in 3 months down the road. So this is as simple as that. Of course, with factories, with analog behavior changing into digital, then you begin to actually look into analysis. And so therefore, you'll be able to understand as simple as condition of the machines, as simple as movement of people. Let's say you have a factory running the operation with few thousands people, or even as simple as hundreds of people, you'll be able to know where they are. An environmental condition of the factory, whether it is hazardous, whether it is actually not conducive for your workers, and eventually it creates a lot of costs in terms of your insurance, in terms of your injury costs. So these are the things are a part of IoT and Industry 4.0. So I'm looking at very holistic approach on how IoT will be able to actually help for IR 4.0. So I don't have a lot of case studies on maritime, but this is as recent as late last year. We managed to supply some stuffs to Mitsui Engineering Shipbuilding, MES. The head office is based in Osaka. So I think their plant is in Oita. So they call it MES Oita Works Facility. So they produce materials handling equipment, including container, cranes, gantry, overhead jeeps, and etc. And it handles tens of thousands of parts, and mainly it is produced by their suppliers. So Mitsui, as you know, they are a huge conglomerate. They have businesses in every sector and every division. So this is one of them, based in Oita. So what happened is they have this issue whereby one of the big cranes, or any simple big cranes, will have about 55,000 components. So it is very difficult for them to manage components from different vendors. So when the components come, they need to sort it out, they need to identify the counts, they need to identify the parts is correct. And it's a very manual-based task. Especially we talk about Japanese labor wage, it's going to be very expensive to get them to count manually. So now what they have done after consulting us and consulting several other IoT companies, so if you look at the far right, so solutions supplied by MDT and also a company called Zerafy. So we are the two companies that are actually supplying solutions for them. So now they are instructing their vendors, whatever parts that you send to me at Oita Works, you have to protect it with RFID. So it's as simple as that. So each vendor will receive new order sheet and corresponding RFID. So when they send the item, it will come siap-siap dengan RFID. So without any problem, they will be able to identify. So what happened is they achieve timely delivery. They achieve component efficiency. Of course, the things are protected. And somehow they get to get into IoTization. So because now they are collecting data they have never seen before once parts are being received. So this is one of the case studies as simple as that, because you are enhancing the visibility. So for example, let's say as a boss, you want to know what is happening around the plant, whether workers are working, whether your goods are shipping out, whether your fleets are actually delivering the products. So as simple as that. With better visibility, you make better decision. Same like even warfare, even probably the general admiral would like to know how many ships I can deploy now so that I can go to war, how many battle tanks I can deploy. So visibility is very important in most of the cases. Okay. So this is as close that I get for maritime industry. But I have other case studies that I want to share with you. Probably it may be applicable for your solutions or for your operation. So one of them, which is one of our biggest industry, in Industry 4.0 will be semiconductor. So semiconductor guys, we have actually quite a fair bit of clients, 3 of them, in fact, they're all Fortune 500 companies, are actually adopting work-in-progress solutions from us. So what happened is we try to automate and try to, like I said, they have a lot of legacy machines. We make their legacy machines smarter in a way by shoehorning some parts and some devices. So in a way, this is one of the areas why we look into the wire bond machines in semiconductor firm, wafer saw machines, surface mount machines, and die bond machines. If some of you who do not come from semicon background, this may be alien for you, but of course, it's all about how you fit in raw material, and raw material create the product, the finished product. So, of course, with the implementation that we have provided, we are now able to see the status, the movement, the aging, the condition, the inputs and outputs, and the revolutions per cycles for the machines, and also, data of raw materials and finished products. So these are the things that we look into. So of course, like I say, we've done the Malaysian plant, and now we are doing the Tianjin plant in China, and also the Bangkok plant in Thailand. All right. So next, beside the semiconductor case studies, also important for Industry 4.0, you look into OSHA, occupational health and safety. So then again, we have also sensors and solutions to look into wireless sensors to monitor fixtures, wireless sensors to monitor workers' health status. You can probably create a command control center to determine what happened within your operation, within your plant, and probably predict maintenance, repair, and etc. So one of the things that we have overlooked, and probably the first world country or even the advanced country, talking about Europeans and Australians, probably Americans, they are they like to look into this far more than Malaysian. Malaysian probably we overlook this. This is what we call workers monitoring for OSHA. So it's not really about infringement of privacy when you track and trace where your workers go. It's also about safety and health check. So because there are statistics even published by Malaysia, occupational diseases like noise-induced hearing loss in factory is very noisy. You have hearing loss, and musculoskeletal disorders. So these are the common injuries, and injuries can cause burden to healthcare, to our own healthcare, our own MOH healthcare, and also probably to the company insurance as well. The loss of GNI, the loss of human resources, it's very important. Therefore, I think even there is also a research stated that the cost of injury and deaths are more than 5 billion as a whole in Malaysia. So this is a very staggering amount that we need to look into. So what are the things that we can actually look into or offer, for workers and health safety check? So it's as simple as workers wearing a wearable. Wearable will be able to detect their heartbeat, their SpO2, the oxygen in blood, whether they are fatigued, whether they are not fatigued, whether where they have been within the scope of operation. And then if you look at the video behind, there's a command and control center to determine where they are, joining the data of Google Map to actually have a trail, where they have moved. And also, what will be the current status, whether they probably have a fall, devices can be bolt on with altimeter, when they fall from 20 stories down, and probably they are injured or died. So these are the things that we look into. Of course, it can be, a little bit back, not too advanced. It can be as simple as probably sewing an RFID tag to the uniform, and you walk in and out of the doorway. It will be detected as well. So at least you know where they are. So at the end of the day, when you do a roll call, a fire broke out, a disaster occurred, the building collapsed, you do a roll call, you are able to identify whether the people are all accountable for, rather than you do not know, how many people are still inside the building. So these are the things that we look into, right? So, of course, talking about people, it's also important to talk about the fixture, because there are occurrences whereby the fixture will be, let me see if I can, oh, media not found. Anyway, I wanted to show you a video whereby the forklift driver actually banged into the rack, and then the rack collapsed, and it caused a chain reaction. The whole entire warehouse collapsed. So this is one of the examples why it is also important to monitor your fixture, because this fixture can be hazardous to a human being. Your fixture may not be only the integrity of the impact, whether it will sustain certain accident, probably as simple as air quality in your environment. If let's say it is too poisonous, it is too dusty, it will create respiratory issues with your workers. So these are the things that you can implement sensors to help you understand your work environment better. So again, this is one of the so-called tracking solution for a rack solution, which we implemented in Sydney many years ago, whereby to counter to what the accident happened. So when a forklift driver banged into the rack, we wouldn't measure the G-force, whether it's half a G, 0.8 G, or 1 G, anything 0.8 G and above, you need to actually repair the rack. Otherwise, it will cause a collapse. So it's as simple as bolting on a sensor, a wireless sensor. You don't need to do a lot of wiring. It's battery powered. You don't need to actually, prepare electricity. So it's as simple as that. So this is what we always do by bolting solutions into your environment. Of course, those are the 3 or 4 case studies that I have and experienced before, because we do implement those kind of solutions. But of course, I just want to share with you there are more success stories and benefits of connected factories. So these are some of the summaries. So one of them is probably, we look into solar farm, a simple solar farm. Solar farm produce electricity and will be fit into the grid, as AC current. So of course, when you talk about production of energy, you always look into the productivity of solar panel, productivity of the inverter, and also the energy loss when you do DC power, which is traditionally what you actually harvest from solar, into AC, which is what is actually used by the grid itself. So these are the loss that you do not know in the beginning. But with now the technologies in place, there are things that what we call smart inverter will be able to detect which panel is not working. Probably there are some as simple as bird poo, covering it, or probably it's dirty by dust. You just have to clean it up, or probably the cell itself, the solar panel itself, is malfunction. You have to replace it. So there are statistics, by having connected PV cells, you are able to actually increase the productivity. We'll look into the bottom statistics, from this is covered module with cloud. With 83%, you can increase to 97%. Broken module from 66% to 94%, so on and so forth. Broken module, which means the solar panel is not working. So we're able to streamline and also boost up the DC power when necessary. So this is one of the solutions that can be implemented and have been implemented. And then one of the Korean companies, pharmaceutical companies called Hanmi, they have implemented a very simple RFID tracking and tracing for inventory, and it's immensely successful for them to actually reduce loss, and also for them to instill first in, first out, especially when we talk about pharmaceutical products. It is important to actually implement this rule. You don't want your old stocks to be actually sitting down in your warehouse and then it expires and then you have to discard it. So I think Hanmi has received much talk about articles and publications by RFID journalists. And one of the Italian steel pipe makers, they have also implemented some sort of active RFID production, RFID tracking, in tracking and tracing raw materials for the steel pipes. So this is also very successful and immensely popular as one of the case studies that factories have looked into IoT, RFID, or even SCADA system that is being modernized and made into IoT in order to understand more what is happening within your operation. So this is a very successful case studies that we always talk about. So with that, this is the last slide. So hopefully, we can go for lunch now. I'm also very hungry. So just to share with you a few takeaways, these are the performances gained, in key sectors. Unfortunately, GE, which published this data, didn't state the performance gain for maritime, for shipbuilding. But you can look into it, the aviation industry, power, healthcare, rail, oil and gas. If you save just 1% of the cost due to your increased visibility in understanding your business, increased visibility so that you understand and predict what is going to be happening, and eventually you increase your efficiency and reduce costs, this is what you're going to save. You save 30B, 66B, 63B, and so on and so forth. So this is the saving. Having said that, I also read on the screen down there, the preparedness of the Industry 4.0 is 2.9. I think it's out of 5 on the scale, right? So at least we are more than 50% past. So what my point and my stand is, we just don't have to talk about IoT. We implement it because the cost of connectivity is so low. And you don't start somewhere, you don't plan for the day after tomorrow, you will be doomed. So that is what is happening to Nokia, Kodak, and a lot of companies, which always much talk about. So having said the day after tomorrow, so why I brought up this topic is I had an opportunity to attend a speech by Peter Hinson, is a Belgian entrepreneur. So he wrote a book called The Day After Tomorrow. So he states that if you invest your time today, today's time, for your tomorrow benefit, you gain a lot more. But you invest your time today to work on today's things, which means you are firefighting. You don't get a lot of benefit. But you invest your time for tomorrow or day after tomorrow, you gain immensely benefit. So that's why it is important to pre-plan. So I think it makes sense. All right. But of course, he has a caveat. He said that it depends on what kind of shit of yesterday's that you have to clean up. So with that bombshell, I end my presentation. Thank you very much.
Thank you, Mr. Sim. Distinguished guests, ladies and gentlemen, now that we have almost completed today's event, we would like to invite Yang Berbahagia Dr. Muhammad Yusuf Sulaiman, President and CEO of MIND, to give his closing remarks. Ladies and gentlemen, please welcome.
So Sim, I'm the one who's standing between you and lunch. So they'll come after me. So Assalamualaikum warahmatullahi ta'ala wabarakatuh. And a very good afternoon. I'm going to make it very, very short and brief. But really, I have to thank, on behalf of Mike, to thank a lot of people for making this event possible. Firstly, I'd like to thank our co-partner Amim, represented by Tan Sri, Ahmad Ramli and colleagues. And also, I would like to thank the other supporting organizations, MITI, Rina Imares, and others, which I not can remember every organizations. But thank you for your support. Thank you to everybody for being here. I'm sure it's a big effort to leave your business, making a lot of money to come and listen and be educated in a way. about the Industry 4.0. And I also like to thank the team in MIT. The MC, I think, has done a great job, Bagat, and also the team led by Rushdie from the My Foresight Institute, the MIT. So everybody, thank you very much. I'd just like to draw on about 3 points which have been mentioned by the speakers today. One, if you look at the Industrial Revolution development, the shipping industry was the first to actually revolutionize the industry when the first steam-powered vessel was created. So you were the first in industrializing the industry. So in a way, then you ask yourself, should that mean that you will not be involved in revolutionizing the industry further on? I think the challenge today was that you need to. And you have shown the way for other industries in the past, and now you have to show yourself how you can actually move and become competitive again. Second was mentioned that by my Joint Chairman Tan Sri Tajuddin earlier when he spoke to Prime Minister, follow the aerospace approach. I think what he meant was that the development of industry has to be supported by a very conducive or very supportive ecosystem. And if you follow the aerospace development since 1994 or 1995, when the aerospace industry was contributing almost zero to the GDP of the country, now it's contributing about 20 billion ringgit to the country. I think shipping SBR is around 5 billion a year. Automotive now is going about 60 billion, and rail is about 120 billion a year turnover. So this kind of ecosystem has to be conscious to be developed, and I'm glad to hear that MITI is there to guide us in many of the Industry 4.0 development. I was with a colleague from MIDA just now, and then it's also very, very good to know that a few speakers actually said this, that the local players have the capability to bring us into the Industry 4.0 environment. We heard from whether from the SBSR industry players themselves, or those who are now still at the periphery of helping the industry to embrace whether it's IoT or other technologies. So I think sharing, collaborating, partnership will be the order of the day. We need to have that kind of a attitude towards fourth industrial revolution or Industry 4.0 to learn from others, because there's a lot of things that's happening outside of the industry itself. And in the World Economic Forum, it's mentioned that the industry boundary are now being blurred. Whether in the next 5-10 years we're going to still have a SBSR or category or not, it's going to be possibly renamed some other things. Automotive is now considered to be computer with wheels. It's no longer automotive. It's actually the wheels are only helping the computer to help the thing to move. So these are some of the things that we do, and we will continue to do in MITE, is to invite industry players, to invite the technology providers, to invite the policy makers to come and share among us some of the latest development and etc. And I think I just also want to mention that one other development that we're doing in MITE is what we call a mini exhibition center, because we found that some issues faced by small, medium enterprises are actually trying to get their products into the market, or whether into the users, whether it's government or non-government entities. So what we have is a very specialized centers for SMEs to showcase, exhibit their products, and then MITE will bring all those important people that will make decisions in purchasing your products or services to be there, listen to you, and then to, for a longer time than is possible in a big exhibition situation. So the first exhibition will be launched on the 17th of April. That will be the rail industry's theme. They are going to showcase all the local capabilities in terms of systems, track works, rolling stocks, signaling system, and the rest. And then we'll bring in the people from MOT, we'll bring people from Pasarna, we'll bring people from SPAD at different times so that they can actually, look at your products and listen to what you have to explain to them. So I'd like to open the invitation to the shipbuilding, ship repair communities. If you feel that would be very useful for you there were some speakers just now were also highlighting their products, their services. We could do it in a more structured way, and you can have the right customer coming to you and listening to you. So with that, alhamdulillah, thank you very much for all being here. Thank you to the speakers for enlightening us with many of the development in 4IR and your latest endeavors. So with that, please join us for lunch. Do continue your networking and knowing each other, and hopefully that we'll see each other again, inshallah, in the near future. So, Assalamualaikum warahmatullahi wabarakatuh, and thank you very much.
Thank you, Brigadato. With that marks the end of our forum today. We hope everyone has benefited from today's sessions. We would like to invite all distinguished guests to have a tour of the showcase. Lunch is served at the function room. On behalf of MITE, we would like to thank everyone for joining us today. With that, I end today's event with Assalamu alaikum and have a pleasant day ahead. Thank you.